So Dawn is gesturing that way. Not sure if you saw restrooms on your way in when you were coming through the lobby, but they're right out there down the hall.
Some outside around the corner this way, dodge the wisteria.
Okay, yeah, if you want a little adventure on your way to the bathroom. And then we'd also really just want to give a heartfelt thank you to our host, Judith Apple, and the team at the Padilla Bay National Estuary Research Reserve. They've been really amazing collaborators in getting this space ready, and their support has been just amazing. So before we dive into reviewing the agenda and breaking into our kind of icebreaker activity, I'm going to pass it off to Scott, the chair of the Marine Mammal Work Group, and followed up by Dawn, the Salmonid Work Group lead, and just to kind of welcome us all and start off the meeting.
Thank you, Nicole. Good morning, and oh,
The owl.
being watched. Oh, I see a time. Thank thank you for coming and for being online with the spring meeting. For those of you who are new to Marine Mammal Work Group, we meet 3 times per year, but not in the summer. Try to pay attention to a busy field season. And I'm excited today for this meeting because this is the first joint meeting with Salmonids, and this is in keeping with the strategic plan that the PSEMP steering committee has set up for us, which is try to cross-pollinate more between work groups over time. So we're kind of working through that 5-year plan. I'm excited to exchange ideas, meet many of you in Salmonid work group. Want to thank Nicole and Candace and Taylor for helping this happen, and Dawn. And thanks to all the Marine Mammal Work Groups, both members, both prospective and the ones that are presenting today. I appreciate you stepping forward to share what we know about the marine mammals. More later, that's it to you, Dawn.
Yeah, hi, I'm Dawn Spilsbury with the Salmonid Work Group and coordinator and don't have a chair right now. So hey, open position doesn't pay very much, but we're fun people. We do meet a lot more often than the marine mammals. We're monthly. We might skip on 1 meeting a year, but so we do have a pretty big work plan, and which means I'm just super grateful to Nicole and Candace and Taylor for putting this on, because this is the 80% they're led all this organization. So I really appreciate you all. Yeah, looking forward to some cross-pollination with the marine mammals. We hear a lot of predation on juvenile salmon. Some of our conversations, Scott and I have talked about how do we know how much fish are where. It's a little bit complicated. I still make it simple. And I said, I don't know if I can do that, but I know a couple people that might be able to help us. And so that's kind of how we formed the agenda for today. So, but we're also happy to take this and rip off of it and just take it where the conversation where it's going to lead us. And it's perfect timing because we're both working on, both workers are working on work plans right now. So, and thank you, Hannah, and the partnership for all their support for PSEMP. And Hannah is our wrangler, so she keeps us all going in the right direction. So.
All right, then I think we'll quickly just review the agenda for the day. So we have some welcome announcements. I'll just go over a couple other things leading up to our networking activity where we'll have a chance to move our bodies, move around the room, and talk about things that are really interesting to you right now. We'll go over that really briefly before it kicks off. Then we'll start our presentation. So we have Mila and Chris talking about salmon population indicators. We'll then transition into pinnipeds, pinniped predation on salmon in Puget Sound. After each presentation, we do have dedicated Q&A and discussion periods, wanting to make space for that. Then we'll take an extended break for lunch. We have lunch coming, but we're also really gonna have fun maybe exploring the grounds. We're also going to ask to take a picture with us all here, so don't run off at the lunch period too quickly. Then we'll come back. We have a presentation on marine mammal predation on salmon, focusing on orcas and porpoises. And then we'll kind of start closing out the day. We have Liz Duffy talking about the Salish Sea Marine Survival Project, kind of giving us an overview and retrospective on that work. And we'll close out with group discussion and group reflection of what we've heard, and maybe again in work planning mind where we want it, what we want to do over the next year. For those of you who might not be familiar with PSEMP, just wanted to provide a little bit of context for that acronym. If you're not super aware, it's Puget Sound Ecosystem Monitoring Program. Scott mentioned this, they just completed a strategic plan. So we'll link to that in the follow-up materials, but what PSEMP really does is provide a forum for people to share, coordinate, learn together on monitoring efforts. And that's what we're trying to do today in line with the mission of PSEMP. Okay, and then just like some announcements, again, this is more for the follow-up material, but Salmonids work group meeting next week, you're gonna be busy, Dawn. Knowledge exchange workshop, we'll share links right after by tomorrow on all of these things. And I'll always like to plug in some ongoing meetings. Coffee with PSEMP if you're interested in learning more. It's an ongoing opportunity, and the Salish Sea Roundtable is a great ever-changing in the topic areas, but we'll be sharing up that link as well. And related, some other announcements. MAR proposals, successful MAR proposals have been announced. If you're not familiar, again, we'll link to all these things. It's work planning season and relevant to your work group, Dawn, just plugging that the Puget Sound Salmon Recovery Hub has launched.
Guys, it is pertinent to all of us.
Oh,
It is all.
it is. It's
Yeah.
Yeah,
Because
sorry.
everything's about to.
I just saw the. Yeah. All right, so without further ado, we'll get into the networking activities. So for in-person, what this looks like is when you came in, you put your name, affiliation, and highlighted something you're working on professionally or a passion project personally that you want to talk about more. So for the next 7 minutes or so, we're encouraging folks to get up, maybe talk to someone you haven't before, and just share, have like an exchange of what you're working on. After 6 to 7 minutes, we'll like call a swap, and you can find another partner to share with. So this is really just meant to get you moving, get you talking before we settle in for presentations. And for virtual attendees, we'll be placing you into breakout rooms, and you'll be sharing out your personal passion projects or things you're working on for the next 10 minutes or so. So with that, let's mute the room and everyone can get up and start chatting. So I'm gonna hand it off to Dawn, who will introduce our speakers.
Yeah, so I get the great privilege to introduce the next two speakers will do them at the same time. But first up, we're gonna hear from Leela Kendall. She's the research biologist and research biologist with Washington Artificial Wildlife. She's also our indicator lead, so is responsible for updating our status of populations and helps us with the key messages on that for the state of the sound vital sign work. So, and then right after Neela is going to be Chris Jansen. He is a conservation plant biologist with the Northwest Indian Fisheries Commission. And so they're going to talk a little bit about fish, the database that we count that fish numbers go into that tracks populations and a little bit of the terms there. So yeah, a little bit from the state side, a little bit from the tribal management side. So there we go. Up to you.
Yeah, thank you. Wait, so I don't need to use the microphone.
If you want it, let me know.
Okay, well, I'll stand here, but maybe.
It's not on.
It echoes like it's on, but it's not.
Okay, yeah, right, yeah. So I'm Leela Kendall, Washington Department of Fish Wildlife, and up here I have the links to the state of salmon, which I saw the 2024 just came out, which is exciting. And then here are the Puget Sound vital signs. I'll talk more about those, but
So pointed at the laptop.
there we go. Yes. Okay, so we're trying to follow the guide that's in the agenda. So I was going to start by talking about salmon population monitoring basics. So how do we count how many salmon we have out there? So how do we monitor and survey? So we obviously have salmon have multiple life stages as discussed in the glossary. Juveniles are monitored at many smolt traps. That's not our focus here, so we're not going to talk about that. We'll have to talk about that later if people are interested. Our focus here really is adult monitoring. And so by adults, we mean fish that are returning back to spawn in fresh water. And so we get a number of fish. So we call it a population abundance estimate. So we talk about spawners or escapement, and those are actually different things, which I think Chris is going to talk. You mentioned that. Those words, but they mean something important, and that is in part why we have our new database, so we can specify those spawners of fish actually make it to the spawning ground, and escapement are fish that get past a certain point, but may or may not actually get to the spawning grounds to spawn. We also are talking about hatchery and exogen proportions. That's important because NOAA, when they defined recovery goals, said that the natural origin, naturally spawning fish are in most populations the recovery quantity. We also have data on age composition, so it's important to know, are fish getting younger? Are they age proportions staying the same? There's talk about a lot of jacks, which are young males, and being very blended in some populations, so we need that information for that. And then how can we extrapolate to the entire population? So oftentimes, to monitor fish, you have the state and you have state WFW staff and tribal co-managers who work in a given watershed. And what typically is done is in places where you have a watershed where it is co-managed. They often say WFW is going to walk, say, going to survey either the South Fork, and the tribal co-managers are going to do the North Fork, and then at the end they get together and talk about their data. And so it oftentimes, so they only survey parts of the river because other parts either they may not have enough staff to do it, or it may just be totally inaccessible. And so basically at the end you say, okay, well in 1970 we surveyed the whole river, and in the indices are 26%. So now we're just going to extrapolate that to the entire population, even though it's not 1970 anymore. But anyway, we unfortunately have those challenges in places, but in other places we do the whole places. We'll get to that more. But the point is that it is not an easy process. There's lots of complexities, but people are working really hard to do the best. So to turn it over to Chris to just talk about salmon biology and then kind of lead into the rest.
So it's going to be very basic biology. So if you're a Salmonid person, you're probably going to be a little bit underwhelmed. If you're a marine mammal, you still might be a little bit underwhelmed, but hopefully less underwhelming, I don't know. So all salmon go through a similar life cycle, right? So we're all familiar with kind of the egg to smolt to oceanary to adult to maturation. All species of salmon go through this life cycle, but what differentiates most of them, besides some of their morphology, sort of how they go through and at what time they experience these exogenous feeding life stages. So I'm going to kind of go over the salmon, specific salmon species and the steelhead species in the Puget Sound area, and kind of go from a very basic life history strategy to a bit more of a complex. So pink salmon are odd year returning fish in the Puget Sound area. That means every odd year you have a return of pink salmon. They are all the same cohort. Every other year is the same, essentially the offspring of the same cohort. There is no cohort mixing or differential cohorts. They are explicitly fry migrants. So the minute they grow and become endogenous feeders, they start migrating to the ocean as fry. They spend a week maybe in the fresh water before entering the marine environment. Coho salmon are a little bit more complex, but they are again 3-year cohort. So every 3 years, the same cohort is spawning over and over again. Not the same fish, but the same cohort. So every 3 years, the returning adults are related. And the following 3 years, those will be related to the previous 3 years. So it's a 3-year cycle. They have a bit more of a complex freshwater stage where they spend about 18 months in the freshwater. So they migrate as what we consider yearlings to the marine environment. Chum salmon have a bit more of a diverse maturation timing where they actually have multiple age cohorts spawning together. But similar to pink salmon, they are all fry migrants. They spend very little time in the fresh water as juveniles. Sockeye salmon, very few populations of sockeye salmon. Some are not even doing very well right now. They tend to have a lot longer freshwater life history strategy going on, so they'll spend 1 to 2 years in the freshwater environment. And then the adults that come back also are diverse cohorts. So you have 3, 4, and 5-year-old sockeye that will spawn at the same time. So you have mixtures of cohorts that are spawning for sockeye salmon. Chinook salmon, probably one of the most well known, I mean not well understood, well known, find everything new about them. They have a lot of mixed early life history strategies. So you get fry migrants, you get hard migrants. So after like 3 or 4 months in freshwater, they migrate. You have yearling migrants. So the juvenile Chinook have a way more diverse early life history strategies, at least that we're aware of. That helps to spread out the risk and provide for opportunities to access resources at different times and help support the population. Subsequently, we have a lot more age distribution of adults that come back to the spawn. As Neela mentioned, there's lots of jacks in some populations. Most populations are spawned by 3 to 5-year-old adults, so you can have 4 different cohorts with intermixing across the spawning a year. Then steelhead, probably I would say the most complex of any anadromous species that we have in the West Coast. Highly variable early migrations, anywhere from par to 2 3-year-old smolts. So you have a wide array of juveniles that are going out. They are not, let's see, I gotta get it right. They are semelparous, they're interoparous, not semelparous. So all salmon are interoparous. They spawn, they die. Steelhead are interoparous. They can repeat spawn. They can come into the freshwater, spawn, migrate back to the ocean, come back, spawn again. That's pretty. It doesn't happen very frequently. It's a low rate of kelping anymore, but that can happen for steelhead. So we have a large, diverse, mature age structure as well for steelhead when they come back. So when we talk about different species of fish, and even within species, we have run timing, and which is essentially we consider the timing that a fish enters the fresh water. They either enter as mature or are maturing. Some species like spring chinook, coho, sockeye, and summer steelhead spend a lot more time in freshwater as adult fish maturing in the freshwater. Though coho is not that extended of a maturation time in the freshwater, whereas spring chinook, sockeye, and summer steelhead might spend anywhere from 4 to 8 months in freshwater as adults maturing after having been to the ocean. Other species in runs like fall chinook, chom, and pink, and winter steelhead all enter freshwater in a mature phase. They are ready to go, ready to spawn, ready to dig red the minute they hit the fresh, I won't give it that much time. They are ready to start spawning the minute they hit the fresh water. And then spawn timing is essentially the range that fish spawn. And so like fish don't necessarily all spawn at one time. They range in their spawn timing over couple of months to several months. And there's considerable overlap between species. So oftentimes we have mixing of, especially when we have pink salmon, like this year, there will be pink salmon overspawning with Chinook salmon, which makes counting and estimating Chinook adult returns much more complicated if you have, I think we're estimating like 20 million pink salmon in the sound this year. So there's gonna be a plethora of pink salmon just spawning over and on top of Chinook, right? So it's gonna be a difficult, challenging year for field folks to like distinguish. Is this a Chinook red? How many Chinook reds do we have? What is our Chinook abundance when we have millions of pink salmon out there? Then turn it
Yeah,
back.
so here's your cool, I think this is a really cool thing about, so we talked about pink salmon, actually, and it was interesting, it kind of was like the fish that, the pink salmon are doing better in Puget Sound, and like, I think steelhead are doing kind of worse in Puget Sound, so it was kind of interesting, and you can kind of see how life history does, in some ways it's related to how well fish are doing, but, so in Puget Sound, we have one run of even year pink salmon, and they are in the Snohomish, and they're actually more related to like even year fish from like BC or Alaska, the nearest place, than they are from like fish that spawn in the same river in the odd years. So anyways, pink salmon are really funky in that way. So, okay, so who collects the data? So I talked a little bit about this, the state and the tribes collaborate. And so I think this is really important that that in each river system, the WWW district and area biologists work very closely with tribal co-managers and again divide it up often to see who's gonna work where, and then at the end of the season and throughout the season, you know, talk about how things are going and kind of what data they collected, and then talk about and then come together to decide on an abundance estimate and report that and then do forecasts. So it is co-management. So data are collected in a variety of ways. So we have reds, lives, and dead. So reds are the salmon nests. We oftentimes do, so reds are more common for fish that spawn at lower densities. Chinook, steelhead, lives are often done by, and oftentimes you either walk or float for reds. Lives are more for, often helicopter or plane because these pace numbers are higher abundance. And we also have, so it just, again, depends on the life history and how many there are. Sonar, so this is a camera right here that you stick in the water and you can count little blurs that go by. Mark recapture, we have a really cool genetic mark recapture in a number of places. And so basically you know how you mark a certain proportion of the population. You can either mark them by physically tagging them with like a Floyd tag or a hit tag, and then, or you can also collect a little fin clip, and then you recapture them later on. And of the recaptures, you say, okay, we're out here and we survey, we're snorkeling a stream, we see 5 fish that are tagged and 10 fish that aren't. So that's, you know, 25% to 33% of the population, and then you can extrapolate it to get a total abundance. You can also do the genetics where you know how many juveniles, and then their parents would be the mark, and then the recapture would be the juveniles coming out. So that is used in many places. And then finally, weirs. We have cameras or just manually passing fish. This is an example of a weir. So we actually, my group at WWW is doing a really cool project on Samish River steelhead. We're actually using all of these methods and try to compare the total estimates to see how they compare with each other, because we don't really know how much sometimes they're using one method in different places, but it's hard to understand how they compare. So why are different methods used? Yeah, depends on the species, the life history, and the watershed, and a lot of times just resources too. It's expensive to do this work. So someone said salmon counting is like counting trees, except they're invisible and they move. So we have all this cool data. The co-managers work together to come up with an estimate, an abundance estimate, and we have worked in the last few years to come up with a new database at the state. And Chris will talk after this about the co-manager perspective on this new database. and it's called Salmon Population Indicators, or SPI. And so here's an example of the landing page. There is the data set, you can send it out. It is public. Again, it's on data.wa.gov, which is our state's repository.
Google.
It's state's repository for, data of all sorts, people and health and, fish and I don't know what else, but I'm sure there's a lot of stuff out there. So this database we based it on PSEMP, is that another acronym that starts with a P that I get confused, which is Pacific Northwest Product
Monitoring partnership.
Yes, so that is based on, they do a lot of work in the Columbia River Basin, they're based in Portland, and this is their coordinated assessments. I think partnership would be the P, this is what Chris has this, so I wanted to include this acronym, but the coordinated assessments database. And we based it in part on this database because there are many fields and each field is well defined. They have this really great data dictionary. I should have included the link for the PSEMP coordinated assessments, and so I totally can do that. Again, you can Google it, but and also you can verify if data are measured at the population scale. It talks about if they're escapement or if they're spawning abundance, which we talked briefly about earlier, and they've had many years to kind of have people assess it and give feedback on it. And so that is why we were like, why reinvent the wheel? There's a great product out already we can base our Puget Sound one on. And you might ask, why would we not just put our Puget Sound and coastal data into PSEMP? And the Puget Sound and coastal tribes said, we want to see it at the table. And at least that was my original understanding. Chris can talk more about this. We do not want to just put our database data into a database that we don't have a seat at the PSEMP table. And so that is why the state started this new database specifically for, we have all of our data in it, and then basically the data for the Columbia River Basin gets sucked automatically into PSEMP. So this is our state, again, it's only Washington, sorry, the key now, it's sucked into coordinated assessments. And it is tricky because you can have, this is only Washington, and of course, many ESUs and DPSs go across state boundaries. And that is something we're working on and people bug us about. And we say, please, if we had more resources, we would love to include more populations, but this is what we have for now. Okay, so we have, you can go there, but you can go in, spend hours on it, but that's going to make much time in it. But basically, you have the population name, ESU or DPS, which is the group of group that the population is in, escapement versus spawning abundance year, like fish are collected using different methods over time. So we try to, like from, these early years, it was collected by airplane, and these middle years it was collected with market capture, and then that's something like that. And we kind of differentiate if it has changed because sometimes then the data are not comparable over time. Contact, again, best value, the fraction of the population. Did we, is this the entire population or have they not extrapolated it? Natural origin, hatchery origin, total, if that's available. PHOS, which you can get from those numbers. What is PHOS? Proportion hatchery origin spawners or escapement. But we like it. Yes, it's just this number that people get using.
Don't think we want for country orders.
Yeah. Yeah. Confidence interval. So this is really cool. We are really trying to have a place for these because again, like we know there are not 560 fish in the river. There is a confidence, but we are working, especially some of our new methodologies are attempting to put confidence intervals on these. We have now a place for that. Age composition, and then the data stats. And we thought this was important because it has been reviewed, it has been co-manager agreed to, so that we are asking our people who are interested is to classify around that so that the people who go in and look at it have a better understanding of, how can we use these data, how okay, the geographic scope is just Washington for now versus Columbia River Basin in the coordinated assessments. How data get entered? So yes, co-managers collect data, agree on the data sets, and then WFW district area biologists enter data. And I will point out, for example, that we've had a challenge with our Nooksack River data for Chinook in particular. It's a tricky population because you have two populations that spawn in slightly overlapping spawn timing, and they aren't necessarily, the spawn timing and the river don't go together super well. And so you might go in there and be like, where's the data? It's because it hasn't been co-manager agreed to, and so we don't have it entered yet. We're currently actively working, meeting with our co-managers to try to agree on a data set that will then be entered. Current uses of the data, so, we have the state of salmon report, which I think was out on the front desk, maybe some of you got that, and then the sound vital sign indicators. I have a ton of slides on these, if people want to, I just didn't want to put them in so that, we can hide. Yeah, so, yeah, so Chris wants to go too, but anyways, I'm happy to talk more about that, and it's just, I think we have really hit this with our new database that actually classifies data as specific types. We feel much more confident in our ability to report, for these two different reporting exercises. But of course, there are still so many limitations. If you go in, you can see that we have that 17 of 32 steelhead populations do not have data that we feel we can actually use to look at status and trends. So it is definitely still a challenge. So our goals of the state of salmon in the vital signs to report on status and trends. So how many are there? Are they increasing or decreasing? And how many there are in comparison to a recovery goal? And then categorize overall conservation risk in state of salmon, and then indicator progress and target status for the vital sign.
I was expecting more.
Okay.
It's a different version.
I know, I cut out a bunch because I was
That's
like,
right.
if people want to, I'm happy to talk, but people want to.
So I'm gonna try to present just, I hesitate to call it a tribal perspective. Although I work with the Northwest Indian Fisheries Commission, I do not speak for the tribe or any of the tribe, I just represent them and support them technically. So this is my perspective as a commission employee on the tribal perspective, so there could be a couple of removals. It is important from the tribal perspective to do monitoring and affect this data. It's required under USD Washington. It ensures that we're meeting our management goals and our expectations, and to be able to adjust our management goals and our expectations and our management intentions. Successful harvest management requires accurate data for forecasting, adaptive management, and meeting our statement goals. We also use it, tribe will also use it to evaluate some of the restoration activities and the effectiveness of that. However, as Neela mentioned, the coordinated assessment program, the SPI data that the SPI database is built on, was developed out of the Columbia River Basin. The Puget Sound Merchant tribes under USB Washington, the Columbia River is not part of that case area. So they were not engaged or involved in the development of the coordinated assessment program. Additionally, I would argue that part of the SPI database is to meet WDFW's legal requirements to be able to have publicly accessible data to the public. I minimize some of the FOIA requests that they can just say, go here, the data's here, go here, right? However, that doesn't necessarily meet the goals of the tribal co-managers. One of the aspects that you see with the SPI database is it distinguishes between hatchery origin and natural origin fish. In many instances, tribes consider those the same fish, regardless of where they came from, they're the same fish. And both are critically important to tribal communities and to tribal fisheries. And both support continuing the maintenance of stocks that are strong. Hatchery origin fish in many systems support the maintaining of natural origin returns in subsequent cohorts. So tribal staff do not necessarily rely on the SPI database. The data that goes in there may be tribally agreed to, but they are not, tribes are not necessarily going to that database to be, this is where we're pulling data from. They have generally house it internally at their own location. There's also a history, and while things have improved, there's a history of state agencies acting as authority on data and disregarding tribal co-manager input on that. So there's a history of that. I will acknowledge it's getting better, but that history is still there. And so therefore there's some reluctance to participate in some of those larger processes. The SPI uses, one size may not fit all. So using the SPI database to an analysis or inform state of the salmon report might not be appropriate to evaluate status and trend at the population and regional level. Generally, the tribes oppose the use of SPI or any tribally agreed to data for those types of processes without engagement and evaluation from the tribal co-managers to inform the interpretation of those results. So I hate to land on that as sort of like the final, but I kept like trying to figure out how to do this without like put a joke or anything else.
But I feel like you engaging recently, like that's kind of why we're here.
Yeah, so.
You don't need to dance, you just engage the Canadian. Okay, perfect. Yeah. So the reason why we brought this subject up was because we were trying to tie it back to the indicator for resident orca in timing, and the desire to try and tie it to run, to salmon run, sizes, timing, where are they, when are they? And Scott and I were talking about this, and he said, well, where do I go? And this is one of my questions for you all, and then, I guess then we can go to questions in the room. But where does one go when they're trying to figure out Thai orca residency to salmon? Where does one go to find out the data? And so this was to kind of help illustrate that when counting fish in the Puget Sound with the co-management scenario, when you're trying to recover ESA listed species that are by population with different run sizes on top of one another, it's incredibly complex. It takes time, and having to get those numbers and having a live run number is really difficult for all of our salmon. We've got such complexity here. So we aren't giving up on figuring that out. We just don't have an answer yet. So hopefully this helps kind of illustrate how complex it is just to count salmon. And then we have the very large catch agreement, North of Falcon process that relies on this work. So there's a lot of very big political treaty trust resource implications to the numbers. So I wish we could, you as fish people, read these numbers, go to a database, you know, but there we are.
But we have made progress, at least for the, you know, for the
Yes.
populations in freshwater, we now have a, you know, an accessible database that is easier to understand.
Yeah, it's a matter of interpreting the data for the specific use that you're using that information for. So, and we're all scientists here, we're all data nerds, so we get that, you know, you can take a number, you have to understand it, assumptions and implications behind it, and the tribes are very sensitive with a lot of this data for very good historical. So, my question for you all, if you have a recommendation, where would one, and if it exists, it might not exist, where does one go if you are a marine mammal work group member and you want to tie residency of orca to salmon population? Where do you start? Is it the trawl work that's done out in the ocean? Is it going to each of the individual tribes to ask, is there a good? No.
So
Yeah.
from that level of information that I think would be informative and useful to inform orca residency, you're essentially building out salmon abundance from escapement to harvest and terminal to the pre-terminal to the mix, Appalachian, Alaska, and Canada, and forget Canada, who has their own monitoring. So that's that whole level of harvest management and accounting is a complex beast based on models that we use for harvest purposes. They're the best we have for harvest purposes, but they are not developed to inform like overall abundance in the ocean area. You could use the CTC AI abundance index that they developed for the Alaskan fisheries, but that's going to focus in up on Southeast Alaska fisheries and not necessarily what's entering That's my answer.
Yeah, well, go ahead.
And we have some questions online as well, so.
Scott, Canada, and then online.
Just to like give a practical example, like last fall, the Southern residents spent an extraordinary amount of time in the northern central basin of Puget Sound. Sort of focused on the Possession Sound, Main Basin Junction. So that got me curious about which salmon are they seeking? If fall chum is so the conceptual model is like, oh, it's fall chum, that's why they come into Puget Sound in the fall. So I guess the question is like, would the SPY database inform fall chum in Puget Sound rivers, or should we partner with tribes that are counting in particular rivers fall chum, or is there a solution there, or is it a data gap?
Did folks hear that question? Okay.
So I guess from a, the SPY database, its goal is to report on populations that are monitored. And so you could go there to get population specific escapement or spawning abundance. So it wouldn't tell you necessarily, you know, it would only tell you, you know, the abundance, like if there were a lot of fish, like in the Nooksack versus the Snohomish, I mean, maybe that would be of interest.
Yeah.
So yes, that is in part why it is there, is a one-stop shop. You can filter by species, you can filter by river.
I'll follow up, does the spy, so chum are very ubiquitous as far as occupying small streams and just about anywhere they can find water.
Yes.
Does spy have that level, or is it primarily the larger basins like Nisqually, Nooksack, you are?
Yes, so that, we are trying to do both. We are trying to have, because you have to spot, you have to survey the individual subpopulations, and then they are rolled up to be at the population level. And what's tricky is because the SPY database, again, like for data salmon reporting, we were being asked to report on these high level indicators, which is a population that NOAA defined. And so, but we understand that people oftentimes, care exactly about individual rivers. And so we are still, I think right now, the high level indicator, the population level is more available, but if you actually go to the SCORE website, S, capital C, lowercase o, I can send out that link, capital R, capital E, which I don't even know what that acronym stands for, but it's another fun S acronym. They do have like individual subpopulations listed there. We are really trying to figure out, is the website is just like a disaster, you can't download it, it's really ugly, but the point is data are there, we're now trying to figure out how to roll them into like a data.gov so that you can actually download it, but it's very slow progress, but we're going there.
Okay.
I will suggest that your suspicion about chum being the main target last fall is spot on. The chum return last year was one of the better ones I think we've seen in 5 to 10 years. Pretty good harvest. And returns actually, I guess I remember going down to Kennedy Creek like 2 weeks.
Yeah.
Swimming on top of each other to try to get up the stream. So
They made the Salmon Recovery Council all misty-eyed.
Yeah.
They're so excited.
but where can you find that information, in sort of like a timely fashion? Sort of inform that without being sort of, post hoc looking back, like, oh yeah, that was a good. Yeah.
Maybe the whales are our indicators for fish are there. Like, remember, we use them as our indicators.
Yeah, so, it's gonna be, a few months to a year before we get that sort of full reconstruction.
One last quick thought.
Yeah.
Another part of the PSEMP strategic plan is to partner more with tribes. So I think what I'm hearing is that it's not necessarily all in the database, and it's like, and that what's in the SBI is not necessarily all tribal breed. So
Well, we really are, I mean, I guess, I really feel like people do, like the district area biologists, because I do feel like I talk to many of them, not all, but many of them, they really do care about having a good relationship.
Yeah.
And so, maybe the older stuff hasn't been agreed to, but I would say the newer stuff, and there's that now a checkbox, so that we are really trying to make it more transparent, but yes, we do have historical.
Key points, conversations beyond the database.
yeah, so having conversations with tribes could reveal that there's actually more data than what's currently in spot. Are the tribal biologists doing counts that we don't get into spot?
I'm not actually positive on that for sure. You'd have to ask all 20 individual tribal staff. About that.
It's kind of part of our strategy, is to start asking. Okay, thank you.
Yeah.
That's really helpful.
Want to do one question online and then we'll go to Hannah? Was there one?
Yes, so yes, Alan did ask, is the SPY data co-manager agree?
Answered that.
Yeah, so the next one is, what is best value?
Which I think was, yeah.
Yeah, so this is one, sometimes you have, so this is more for the high level indicator reporting. You sometimes have different organizations that go out and collect data, or data might be at for example, this is more places in the Columbia River Basin where you have like a dam that they have to swim past. You have like a escapement past the dam, and then they actually do the spawning ground. So we would check that escapement value is best value, because that's a thing to say, use that for your state standard reporting. And so again, like if you go to the data dictionary, that's where it kind of talks about those details.
Hannah?
Yeah, thanks, Neil and Chris. This has been really wonderful. Are you able to go one slide back to Chris's last slide? The fundamental issue here, right, is that tribes are generally opposed to the SPY database without meaningful engagement, evaluation, interpretation. I would love to hear from both of your perspective, where that, like, at what level that engagement and evaluation should be happening. It is my understanding is that obviously tribes do not have the capacity for PSEMP to reach out to every tribe, to all 20 tribes and ask for something at the same time that the vital signs staff is doing so at the same time that the GSRO is. From both of your perspectives, Chris, is that the responsibility of the Fish Commission? Is that the responsibilities of individual tribes when engaged? And then from a state perspective, Mila, is that the responsibility of you and your staff? Is that the responsibility of your tribal co-management staff? Where do you see that fitting in so that it's not a million state employees and private sector employees asking for capacity of tribes that they don't have?
So I appreciate you asking that, because that's been sort of like a struggle I've been trying to wrestle with and try to figure out. We've since sort of like the vital sign indicator stuff came up, I'm like, how do we get adequate tribal engagement and on all aspects of that, recognizing capacity limitations that are already existing there. And I think one of the things that I tend to focus on, and while I recognize it's an opportunity for tribes and tribal staff to participate as members of working groups, that essentially relegates them to another stakeholder. And I think tribes would argue we are more than just a general stakeholder as an NGO or a state agency or a regulated agency. We are a sovereign nation that has treaties with the US, and we should be treated a little bit higher. And so where that engagement occurs at, I think monitors of the USP Washington co-management treaties, our state agencies have an expectation to engage with the tribes as tribal co-managers on these things. I acknowledge that engagement, the capacity for the tribes to then invigorate and engage that is going to be limited, I would imagine. I can't say that for sure, but my observation is they are spread so far thin that trying to engage in. Because I also think Canada, like, we're not just like, understand, but all the vital signs, the breadth of the 70 vital signs, we get tribal engagement on all those things. I don't see that happening. So like trying to figure out which ones are the important ones, like we're to key in on that act, trying to be a better aspect. But I think recognizing tribes as sovereign nations and treating them as more than just a stakeholder, like other entities, is the first and important step to that.
And as work group coordinators, when we get tribal input, I have a lot of, the work group, salmon work group has a lot of tribal members that are representatives that come and represent the tribes, and I appreciate them, Deb, and I saw you online. So it's a matter of taking what they have offered and the information they have and hold that. And yeah, that's right. It's a little bit different, and consider what you're going to do with that data and be respectful with it or that information, and what they're advising. So it's a coordinator role.
Do you want to add to that?
Yeah, I guess so. I am like a person who, the jack of all trades, master of none, and so I really get the data. But I guess my observation is talking with our, I'm in fish science also at WFW, the people who out and collect the data are fish management. So they're the ones that are local on the ground, getting the data. And I think that like in a situation where things go well, with tribal co-management, what I've observed, and again, like Chris may have a different perspective, other people may have different perspectives, is that the people who are out collecting the data, the state engages, closely and consistently with the tribal co-managers. The data are collected, in a way that they agree on. They are analyzed jointly in a way that they're agreed upon, and then they are reported. People feel good about the data that are reported, so that then we can, go to a place and get the data, and people can feel good about it. But again, there are challenges at each of those steps.
One more question?
Just in response to the question around in season, because we're at a marine mammal. I mean, you could use maybe not the tribal fisheries, but the state fisheries sort of opening and closing gives you some indication of a strong run. And if it stays open, it's a really strong run. So that's one way you can track the run size in season. If you're trying to figure out like what rivers have a strong run that year for which species, the state does put that out publicly. In tribal fisheries, I don't think you'd be able to get that as easily, but it's similar.
So depending on which state fishery you're speaking of too, though, the way the harvest management plans and annual agreements have been working out. Recreational sport fishers in the marine environment are now sort of in many areas, I don't say all marine areas, but many marine areas are limited by encounters of like unmarked juvenile or sub-adult Chinook, which you might have a good run and hit that in like a day, like, oh, it only happened for a day, so I think, I hear what you're saying, I think they're off, but I think within that sort of framework, you would have to have very consistent fishery implementation and length of fishery and sort of consistent effort to utilize that information to be helpful about some sort of like run size indexing. But right now, I think the way things are having to be managed because of certain stocks and concerns, the consistency of those fisheries are so all over the board. They might be planning to be open for 3 months and they hit their limit in 1 week, and it's like, and the run size might not be that great. It's just they ended up hitting a lot of immature fish.
Yeah.
And that's not necessarily probably immature fish probably not informing as much the run size as a mature.
Yeah.
We also do have a database called Spawning Ground Surveys, SGS, that's at the state. So one maybe could go there to look at, because that's like the in-season thing. We're also trying to move to where the SPY database has preliminary data versus final, and so that we can get our data in earlier. It may not be that it's like completely agreed to, or like it may change as analyses are done, but like trying to get data in earlier, so that exactly people can have data earlier.
If you're interested in non-domestic stocks, like Canadian stocks, like Fraser stocks, PSC, Fraser River Panel stuff, they do a lot of in-season updates for PSC and sockeye salmon there. So that, those data are fairly easily accessible for PSC, but not for domestic stocks. So.
Well, I'm gonna end on one not real salmon related, but it's a really positive story that our marine mammal friends might not have heard of yet. And it's monitoring. So the Nisqually tribe was out looking, and I see John smiling because he knows what I'm gonna say. They were out surveying the reds later in the fall than they usually do, and they saw these really big, huge, beautiful Chinooks sitting on reds and went, "Who are you guys?" Turns out they have now established that they are a distinct, genetically distinct wild run of Nisqually's Chinook they have brought back. And so it just gives us all goosebumps because that was a stock that they really worked hard to bring back using some genetics from some other hatcheries that they now have gone through enough iterations of their population. They are now genetically distinct from their stock that they were used to bring them back extirpation. So that's pretty darn exciting, you guys, and that's because of long-term monitoring. Yeah, just scored right.
Chris, and don't forget we're having a discussion at the end of the meeting, so anything that's on your mind that you didn't get to ask, it can come back at the end of the day. So I'm gonna hand it off to Casey, Liz. Is Liz Allen? Okay, and Dietmar, who will be presenting on pinniped predation on salmon in the Sound. So Candace is just getting it up. I'm gonna give you the clicker. So that
And we've sort of adjusted the order we're gonna go in. Liz is gonna go last thematically, it kind of made the most sense.
Okay.
So it'll be myself and then Dietmar. Be back by then.
advance, there's also a pointer there. And I will say, so our owl is picking up the sound, so if you could stay close to the podium, the mic is not on. But
No, I could have sworn I heard it. Oh, maybe it's just the room.
it's not.
Okay, well, I'll talk loudly anyway. Nice to see you all, really glad to be here. And gonna jump right in. I was asked to give sort of an overview of pinniped populations in Puget Sound. And I'm gonna be focusing specifically on those pinnipeds that are most likely, most likely to be those consuming salmon. Ones that we know are consuming salmon and may in some places be impacting the ability of salmon rates to recover. And so, namely in Washington, I didn't introduce myself. I'm Casey Clark. I'm the lead marine mammal researcher at WDFW. So I'm within the Wildlife Program Science Division, and my team's sort of task is to collect the marine mammal data required for the state to make management and conservation decisions, and also for partners, like in some instances, we'll carry out some of the responsibilities of marine mammal monitoring that NOAA is required to report those data. example. And so I'm gonna be focusing mostly on abundance, and sort of trends through time, talking a little bit about why that's so challenging in some cases to estimate, and other partners that are involved in collecting those data. And then at the end, I just couldn't help but do a little sneak peeks of some things that we've been working on for the last several years because we're talking about. So we're gonna be talking mostly about harbor seal trends in abundance through 2023. Some more recent data, well, some older data for California sea lions and highlighting that as a data gap in a place that we'd love to see updated. And then similarly, some trends on stellar sea lions through 2023. Apparently the order I put slides in is not the order I just ran you through. We're starting with sea lions. Sea lions in Washington are a bit of a challenge, particularly as we think about California sea lions, because depending on how you look at it, they're either seasonal visitors or they leave seasonally to go breed in Southern California and Mexico. And so only for the most part, certainly there are exceptions to this, but for the most part, we see male and adult male sea lions in our waters, and exactly where they go and exactly when they go there and how many are there really depends on what's happening in the environment and what is happening with the food. And so if they go where the food is, that makes it really challenging to know, as we were just talking about, knowing exactly how many fish are where and what food is available in a given year. Is a really hard thing to know real time and much less predictably. And so understanding where we should expect suddenly a big aggregation of California sea lions to show up can be a real challenge, but there are patterns we can pick out there. And we do know there's a lot of these animals writ large. The population as of 2014, which is the most recently published estimate by NOAA, which is based on work on the rookeries in Southern California and Mexico, there are more than 250,000 animals. So there's a lot of California sea lions out there. For all of these species, you can basically assume that pre-Marine Mammal Protection Act, so the 60s, 70s, they were decimated. And now for these species we're gonna be talking about, there's a heck of a lot more of them than there used to be. And so many of these species in Washington, many of these populations are either thought to be or are confirmed to be pretty close to their carrying capacity. But again, for something like California sea lions that are visiting and following ephemeral food resources, the number that might be there in a given year is really going to change. And so there was some work done by Jefferson et al. Published in 2023 that was based on aerial surveys in water animals. And they estimated that they saw in the spring peak abundances of California sea lions and estimated that there were up to about 3,000 California sea lions in all of Washington's inland marine waters. I'm not focusing on the outer coast here. There's some really good work that's been done primarily by Macaw tribal bios and researchers, also by folks at NOAA and some work that we do at WDFW. Those of you that have been paying attention to South Sound in particular in the last, I'd say 10 years or so, might say, hey, peak abundance in spring, that doesn't really jive with what we've been seeing. Certainly at the Nisqually River mouth, we see tons of sea lions, both stellars in California, showing up as the fall chum come in and then potentially posing a threat to the winter chum in that system because they're sort of the last thing on the dinner table. And so maybe they get a lot of the extra predation pressure focused on them. But also since about 2015-16, when we had the blob, the big marine heat wave, we saw a whole bunch of different ecological shifts in Puget Sound. And we had a huge biomass of anchovy come into South Sound in those years. And with it came big groups, like 1,000 common dolphins came in. We never see common dolphins, well, hardly ever see common dolphins in the Sound. We had tons of sea lions and harbor seals foraging on those anchovies. And so that lingered for many years, and there was suddenly this sort of new aggregation of animals every year into that late fall, winter timing, which could then have tack-on effects for salmon runs in that area. So understanding those drivers is something we're working on. Why did sea lions go where? Can we use oceanographic features like marine heat waves to sort of predict when and where they might show up? And to do this, we've been working on tagging sea lions, mostly in the Columbia River in association with some of our sea lion management work there. We've been getting animals as they're coming back up from the breeding areas. So they're in Astoria in August. We're getting these tags on their flippers. These just tell us where they haul out. And if we're fortunate enough, if they're sailing and seem like they do sometimes when they're hanging out thermoregulating with a flipper up, we'll still get check-ins, which has actually been a bonus. We didn't think we'd get any at sea locations. And these tags can last for up to 2 years, which is phenomenal. Most tags that we put on these animals fall off when they molt. These ones have a back plate, they're actually through the flipper webbing. So we put out a few more than 40 tags over the last couple of years. We're hoping to get another 20 or 25 out this year. And just a preliminary look at what we're seeing in our neck of the woods. We of course see these animals go all the way down to their rookeries, but we get some hotspots. You can see South Sound, particularly over here in Case Inlet showing up as a spot where there's a bunch of them. Got a swally down here, and then there's our favorite naval stations scattered throughout Seattle, but up here, Everett, Bangor, Bremerton, those spaces, they love them. They use them as habitat all the time. Some of the marinas in Tacoma, and then tons of use up there in the Strait of Georgia. Hopefully, we're going to be able to take these data and analyze them over several years in relation to some of the different available prey data, oceanographic features, to understand some of those drivers. One really interesting thing we've seen thus far is, at least in the first couple of years, we've seen animals that seem to be inland water animals and animals that seem to be generally coastal animals. And to our knowledge, that's not something that anyone's really described before. We tend to think of the sea lions as just sort of mixing and going wherever there is food. And yes, there's some on the inland, some on the coast, but thus far, even the animals that we're getting a second year of data from, the ones that were coastal animals before, are hanging out on the coast again. And then those are the animals that tend to come to the Columbia when the Yukon come in, for example. So getting down to the nitty-gritty of some of these ecological pieces is going to be really valuable. I think I've spent just about half my time on a quarter of content, so. Stellar sea lions, they are found in Washington waters year round. There was sort of in the 2010s-ish, the official establishment of what we're officially calling a rookery off of Washington's coast of Carroll Island Sea Lion Rock Complex. Now there are hundreds of pups born there each year. So the stellar sea lions are divided into the Western Distinct Population Segment, or DPS, Eastern Distinct Population Segment. The Western exists on the Alaska Peninsula, Gulf of Alaska, and out in the Aleutians, and they've just been tanking hard for reasons people are still struggling to understand. The Eastern DPS has been growing, and though you can see our numbers in terms of the overall scale are absolutely tiny, this population has been growing at about 5% a year. Some periods it's been more than that, and is still fewer than 5,000-ish individuals that are using that rookery space specifically. But of course, all the animals that are in Washington are not necessarily the ones that are breeding there. So there's, like I said, there's been some good work looking at sort of long-term changes in seasonal abundance on the outer coast, mostly by John Scardino and crew at Macaw. And we have contributed to some breeding season surveys. NOAA researchers have historically, continue to, been collecting data using drones out there. But I'd say sort of exactly where, when, and how many of these animals are in the sound in inland waters is much more of an unknown. There are some consistent patterns. There's a lot of use of whale rock in the San Juans. There are other places they'll show up. They show up in Nisqually, I saw 70 of them hauled out on the barge there this year with dozens more in the water. So they certainly are responding to a lot of those same food sources. They're also a lot less habituated to using human structures. And so you're not going to see quite as many of these guys hauling out in marinas, on breakwaters in the way that you would elsewhere. But another data gap in terms of thinking of our inland marine water stocks, exactly where, when, and how many, and how do we want to study that. Harbor seals, we have a much better grasp. There are 4 stocks of harbor seals, either in Washington fully or shared. This Washington coast stock, this Washington coast piece is actually a shared stock with Oregon. It's the dotted lines. This paper that I've taken these data from, we published in 2022, I believe, or 2023. And just gonna quickly run through each of the stocks. You can see a recovery. This pattern will be mostly true, except for the canal. You'll see a recovery from low numbers flattening out, something like carrying capacity. Not going to estimate carrying capacity for the outer coast because it's a partial stock, so we can't really say what's happening at the full stock level. But in Washington, we estimate over 22,000 animals in that stock, mostly in those coastal estuaries of Grace Harbor and Padilla Bay. looking at the northern inland stock, which is of course also shared with Canada, but not acknowledged in the management of this stock, so there's some wishy-washiness there. Heck of a lot of seals up there, over 15,000, and looks like they've been pretty stable for at least the last 10 years or so, and that carrying capacity is estimated, so, yeah, we're estimated to be right at about that estimated, carrying capacity. In southern Puget Sound, there may still be some growth happening, it may not quite have leveled out, but there's about 2,500 animals down there. And then Hood Canal is thought to have recovered actually before this time series began in 1977, or at least begun that trajectory. And since then, it's kind of been wiggling around what we estimate to be a carrying capacity of about. I'm gonna make sure we leave time for some of our other cool work, but I think I'll actually be leading into some of Dietmar's pieces, which is that the thing my program has been focusing on, other than just figuring out how many of these animals are, is figuring out what they're eating. We do a lot of that with DNA studies from scat. And we've been trying to bring all of the genetic methods that were initially developed over 10 years ago into alignment with some of the modern best practices for lab work, and getting way more quantitative than I think we've been able to do in the past. We have also, I'm not going to go into the details, but we've also developed a SNP panel, a single nucleotide polymorphism panel, that allows us to look at the seal DNA in the poop and determine not only what sex it was, but give it individual ID. So when we go out to these same sites, month after month after month, we're going to start getting scats. We know we've started to get scats from the same individual. So suddenly you can get into that question of, are there specialists within this generalist population? Very exciting. And our current work right now is bringing together 3 large-scale studies of Port Susan Bay, Stillaguamish River estuary, and then the Nisqually River estuary in South Sound, and then the Dorsey Wallops and Duckbush rivers into the canal. Bringing those together with monthly drone surveys where possible to get abundance, and then lots and lots and lots of poop scooping for diet analyses. The ultimate goal, which is pretty ambitious, is to get at an estimate of a number of salmon of each species consumed each month, and help us put into the framework of some of these other salmon discussions in terms of exactly how many salmon are being taken by pinnipeds in the fisheries, would benefit from habitat restoration, are starting past dams, and try to get us into the atmosphere. So I probably used way more time than I was supposed to, but I'm gonna with some. Thank you.
Thanks, Casey. I'm Dietmar Schwarz, and I collaborate with Alejandro Acevedo Gutierrez. We're both at Western Washington University. And I'm going to talk a little bit about our work on sex differences between the sexes of the harbor seals and countries of origin. So one assumption that has been made so far when it comes to estimating the impacts of harbor seals or other marine mammals is that all seals are equal, treated equal. They all do the same thing across the entire area. It's one big bathtub that's equally mixed, and they all have the same diet at each point in time and space. So as ecologists, we know that's probably an unrealistic assumption, but it's been difficult to actually get at more details. So in comes scat, poop, and we can learn a lot of things from scat, right? So we can learn about what the seals ate, and Casey talked about efforts to make those measures better. But we can also learn things about the actual predator. So the data that I'm going to talk about is based on determining the sex of the seal by X and Y linked markers. But as Casey pointed out, we now also have the ability to look at the individual identity of seals. But unfortunately, it's not yet reflected in what I'm talking about. So if we look at the overall patterns, and this was based on roughly 2,000 seals, half of them males, half of them females, we see that the seals eat mainly hake and herring, and there aren't that many differences between sexes. But then we see very distinct sex-specific differences. So there are differences. So females tend to eat more benthic fish, whereas there's a bias towards salmon when it comes to male seals. And I caution here, don't take these proportions as reality. These are all, there are biases in DNA barcoding. But I believe the relative differences between the sexes are valid. And so overall, sex actually explains a little bit of the variation. And I will talk about what may explain some of these other differences. So if we are able to distinguish between the sexes and we are able to, due to advances in these molecular techniques, are able to look at much larger data sets, we might be able to start looking at variation in time and space and also variation by sex. So we might have situations where males are hanging out with river mouths predating salmon, whereas females might be more benthic feeders and actually maybe preying on salmon predators themselves. So seals eat all kinds of stuff, as you've seen in the slide before, and some of those species actually also prey on salmon. Okay, so in this study, we looked at 13 haulouts. Some of them we were able to sample for multiple years. Like I said, around about 2,000 seals that we were able to sex. And there were a few haulout sites where the proportion of males and females were roughly equal. Then other sites that were dominated by females. And then other sites that are dominated by males. So it's not just one homogeneous soup that we're eating. There are differences. And at the haulout sites that were able to look at multi-year data, the sex ratio was actually consistent. So what may account for this variation in the haulout sex ratio? So with two undergraduates, Haley Rakoff and Maren Duffy, were looking at this question, and this is work in progress. But one pattern that seems to show up, even though our sample size is really small, is that 4 out of the 5 male-dominated haulouts were close to marinas. And there is evidence that males are just more disturbance tolerant and may accept those sites. So salmon run proximity, at least right now, does not explain this haulout sex ratio and comes right back to the salmon data. Right now, we're just looking at the distance to the closest salmon regardless of how big it is. So we're trying to incorporate escaping data. So what may explain those differences between males and females? So one idea might be, well, males and females may just have different preferences. And so if we have a mix of males and females and they encounter a mix of prey species, the females are going to go for the benthic fish, and males might have a higher proportion of salmon there. The other possibility is that males and females in the same area will eat the same mix of fish that they encounter, but the differences between the sexes arise from the fact that males and females just seek out different haulout sites. And if we look at our data, and this is very, sorry, I apologize for this slide. But so each of these boxes here, so this for instance, Cowichan Bay up in Vancouver Island, is a haulout site, and we're looking at diet throughout the year, and each bar is the diet composition of all these different species that you don't need to know about, or borders. And it's subdivided by males and females in the same month at the same site. And then the whole thing is subdivided by sites that are a 1-to-1 sex ratio, female dominated, and male dominated. And just the overall pattern that I'd like to point you to is that males and females at the same site are more similar to one another than they would be to males at a different site type. And that supports sort of that last idea that it's really like males and females might be seeking out different haulouts, different areas that they're preying. Why they do that, we don't know yet. Could be because of prey, it could be because they're less tolerant to disturbance. So one last sort of mad scientist idea is, we only are able to look at sex of the seals in the diet at the hallmarks where they actually fall out and poop. So what about the sex of seals in the actual areas where they forage? And seals have very difficult to sex them just by looking at them without capturing them. And so we've been messing around with taking eDNA from around individual seals, from the flipper print in Whatcom Creek, and we've been able to get 6 IDs from those eDNA samples. And as it turns out, in Whatcom Creek, where the seals congregate and prey upon returning salmon up in Bellingham, indeed our samples are dominated by male seals, as we would predict given the diet. And one of our most notorious salmon predators named Goggles, because of the markings, as it turns out, is a male, as we suspected. Hey.
I'm gonna keep this really brief because I want to make sure we have your first discussion. Okay, so I'm just gonna tell you guys about a modeling framework that we've developed recently that looks at small scale pinniped management in individual river systems that we're calling gauntlets. And just looking at the effectiveness of different management options within those systems. Yeah. Okay, so we're defining a gauntlet by 3 criteria. We have a system where salmon are migrating through. They hit some kind of barrier to their movement or constriction in the way they're able to navigate that area. And while they're navigating that barrier, pinnipeds have access to them. So in the gauntlet, when we're modeling these systems, we're thinking about a few different dynamics. And we're gonna walk you through like one diagram that has all the pieces in it. So we're really interested in these systems in that sort of individual behavioral specialization that we've just been talking about. And so in order to get at those individual behaviors and decision making, we have an individual based model that keeps track of each pinniped learning about foraging opportunities in the gauntlet and whether prey are available or not. And then also learning about is there harvest activity going on in that system? Is there management? Should they be scared of the gauntlet? And so they're learning about that individually, they're sharing information with each other, and then they're deciding where they want to forage based on those experiences they've been having. And we can feed that into basically how many pinnipeds are going to be deciding to forage in these distinct river systems on a given day. And so once we know how many predators in the system, we can figure out what that means for salmon, and then figure out how we can manipulate the system through management of predators to figure out if we can increase salmon survival in those systems. Specifically when adults are migrating through, they're trying to return and spawn, and that they're just having a huge impact on them on those discrete systems. So this is the modeling framework that we've created to kind of look at those dynamics and see if we can manipulate them through management with the goal of improving salmon survival. And a key piece of this project was engaging with tribes that manage each of these individual gauntlet systems. So we've had a whole bunch of workshops with many stakeholders, with like 60 people engaged from 15 different tribes. And so we ended up looking at this model in a few different case studies. So one of those was one of them was the Ballard locks. And so when I'm talking about these really discrete gauntlet systems, like this box is our gauntlet. So a really small scale spatial area where we're thinking about management by tribal managers on these, in the areas that they're managing. And so in this system, we were keeping track of 3 runs of salmon and then 2 pinniped predators, and looking at those dynamics in this area. We did the same thing at the Nisqually River. So again, really small scale gauntlet. We're looking at the first 2.5 river miles. And keeping track of all of these predators. Again, I'm keeping this really brief, so I'm not going to go into any of my case study results with you, but feel free to track me down if you want to know what management looked like in these 2 systems specifically. But overall, what we found is that what a really key part of effective management of getting these pinniped predators to have a smaller impact on salmon as they're migrating through
is to do management in a way where you're scaring all predators. So, you may or may not be aware that we have multiple options in how to implement management in the systems. And some of them cause fear. If you're chasing pinnipeds around in a boat with a gun, that's pretty scary. And some of them don't, right? So if you're just like removing them off of a trap haul out and euthanizing them off site, that's something we don't expect them to be scared of. And so, we're thinking about kind of, we have all these options for management and what's the most effective, right? So when we broke this down and just looked at, options where we have management that causes fear and management that does not cause fear, and then a no take where there's no management happening, we're seeing that options where we're able to scare predators away and remove them legally at the same time is way more effective. And the key part of this is that's the tool that tribes have access to, that agencies, it's much harder for them to do that type of management. So tribes need to have the flexibility to do that kind of management, to access their treaty right to harvest pinnipeds. And we all benefit, salmon benefit from having access to that treaty right. The second cool part of this type of management is that it also requires that we legally remove fewer pinnipeds. If you're scaring them all away, you don't have to kill as many to get the same benefit for salmon survival. So, yeah, good on both metrics there. And I think I'm gonna leave it at that.
You have some more time if you wanna, but
I think our discussions have been good.
all right, more time for Q and A then. Thank you. Yeah. Oh, Neela, you want me to?
Mine's actually related to this specifically, so maybe it goes next, but it seems like if you, I guess, like, if you remove a lot, like, the good thing about the fear is it's effective, but you have to keep doing it. Versus if you remove a lot, obviously there's a lot more beyond this, but like, can you just like do it like one removal and it lasts for 5 years?
No, absolutely not.
Okay.
Yeah, but you definitely, you need to be maintaining it, and that's something where, the timing, the restrictions on how, like when management can happen in these systems are pretty, limiting at the moment. And so, giving tribal managers the freedom to choose like when that management should happen and how frequent in their system, and like doing that and figure out exactly what works in their system is kind of a key part of how this would move forward. Another like key part of it is that you would have to remove so many pinnipeds to have an effect on salmon survival. Whereas if you're just scaring them away from this area where the salmon are extra vulnerable, you do not have to kill quite as many. They will just replace each other back in the system, so you're doing that, so.
I think we had a couple other questions, but can I get in line for questions? Can I actually? Okay, well.
If I remember correctly, a few years ago, Steve Jeffers was talking about, the abundance estimate that DFW is developing is based on some haul out correction factor, number of individuals in haul outs versus the correction factor in the water. And there was an interest in updating that because I believe that was from like the 70s or something like that. Has DFW tackled that yet, or is that still outstanding?
Yeah, am I in a good place for the owl for the online people, or should I go back up front?
It would be, yeah.
Yeah. So just for everyone's extra added context, so when we fly over harbor seal haulouts and count how many animals are there, there's some proportion of the animals that are not all that right there in the water swimming around. To my knowledge, there's probably never been a time where every single harbor seal is hauled out. So in recognition of the fact that those counts don't reflect abundance, there was a study done, it was actually done in the 90s, but it feels like the 70s now. Where there were hundreds of seals tagged with VHF tag, and then a whole bunch of aerial surveys flown. This was in partnership between WDFW and NOAA, and listening for those each seal on a VHF frequency from the plane. And if the seal was detected, it was considered to be hauled out. If it wasn't detected, it was considered to be in the water. Of course, there's all kinds of other things the seal could have left. The seal, it's other potential sources of error, but the estimate came out pretty consistent. and consistent with other similar work that has been done in other regions. And it's about 60% of the seals are hauled out if you are at peak pumping season in the 2 hours before or after low tide. So it's just really constraining all those variables. And there's been this question, has that changed through time? Like it very well could have. And so we have ambitions to update that. And that's part of that project that I kind of glossed over right at the end. We're using those same tags that I showed you on the sea lion flipper, but we've got them out on 45 different harbor seals right now. And those tags, in addition to giving you sort of course locations, we have a function turned on for the harbor seals that is giving us each hour what proportion of that time, what percentage of that time was spent wet or dry. And so then once we get 2 years, year and a half of yearly daily updates on what proportion of time was spent hauled out on enough seals, the goal is to take those data and get them back into maybe a slightly more refined framework that takes into account tide state, month of year, maybe ambient temperature. We're gonna have to figure out what are our predictors there, but that gets us a more refined estimate. But the short answer is there are others that have looked at this using various different methods, and it seems, even up in BC, seems pretty consistent, but it would be it could hugely impact the estimates if the proportion of the population that's hauled out when we fly those surveys has changed and we've just been using a static correction factor. So stay tuned.
Yeah, I have one for Casey. So, I was wondering if you have reached out or had any communication or plan to with Megan Moore, who's also doing the interpretation sort of in Puget Sound, which would be a this.
Megan Moore is the unacknowledged partner in that work who I glazed right over. So that's one of the pieces of all of this. I'm so glad to see all of us in the same room because this is a fish issue as much as it's a mammal issue, and leveraging our expertise and figuring out how to talk to one another and bring things into a framework that we can all discuss and takes into account all the nuances and complexities of each side is super important. So not only are we looking at this from a seal angle at two of those locations that I mentioned, the Nisqually and the Hood Canal sites, but also NOAA researchers led by Megan Moore are out there putting acoustic tags in out-migrating juvenile salmon and steelhead at both those sites. And so we will, I have this dream of finding one of the acoustic tags in the stats, but we'll see. But we're looking at diet and estimates of predation from that front, and then also survival estimates for out-migrating salmon at those same locations this year, right now.
Other questions? Yes.
So I know in Canada, they're looking a lot at like haul outs and addressing haul outs, specifically like log booms, I think. I mean, how many of the haul outs you found in Puget Sound are ones we could address? I mean, is that a part of the conversation? Or are they just gonna move to a different haul out?
So the idea of potentially removing artificial or even inconveniently placed natural haul outs is a question. It's something that people have thought about pursuing as a non-lethal option. And certainly, I think if you look at those sites that Dietmar was talking about, where there are lots of male seals that are eating more salmon, though they weren't all that way, they do tend to be situated somewhere near a river mouth. And that aligns very closely with that log boom work up in Vancouver Island. We're giving these predators easy access to a space that they want to be in, where they're having impact to fish stocks that we would prefer they were not consuming. And so we've kind of done a natural experiment within Puget Sound and probably regionally, because a lot of the logs are now shipped by truck and not shipped, they're not moved around in the water as much anymore. So the log boom volume is massively reduced, but throughout the Sound, so many of the seals are on at marinas where there's logs or derelict vessels, depending where you are, used as breakwaters. There are remnant log booms places, and they absolutely love that type of haul out because it's isolated from predators and they can just plop right in the water when they want to. And I think in Canada, they even found that the log booms were acting as an attractant to juvenile fish, which then made them even more susceptible to predation by the seals that were hanging out there. Yeah.
But I think on that, I was listening to a student doing something at Western, Alejandro's lab, and they were looking at the removal of the log boom, and it looked like it actually didn't affect how many animals are coming in, but that might be the fact that the haul out that they're regularly using isn't far enough away, right? So if it was really far away and then that boom was there, then they would be coming there more, but because their haul out was here, it didn't matter that the boom wasn't there anymore, and so that's what came in. So I think there's some level of where the haul outs are and where the booms are.
Absolutely, yeah, and we're never gonna make it so that these animals can't haul out in certain places, but I think of it as a gradient of convenience and ease and sort of from an animal sort of physiology perspective, I think of it as energy budgets. If you make it really comfortable and nice to be in the spot where also the food we would prefer they weren't eating is, they're gonna hang out there. And so that's part of the work at the Nisquallies. We've started discussions with, to potentially remove that barge that I mentioned that had 70 scholars on it consistently, is the sea lion haul out every fall and winter. It's in the refuge, but we've talked about, if we can get this out of here, it's not gonna stop the sea lions from coming, but it's gonna make it that much more work for them to be there and make it that much less nice of a place to be. So I think with all of this, as with salmon, as with mammals, it's gonna be an assemblage of techniques and approaches that we need to put together to try to achieve some of them.
Yes, and then we have a question online.
Yes, just a quick question, for DPAR, I'm really interested in those, in the sort of sex-based, preferences for haul out sites. I was wondering if your team, or if you're aware of any work that's happening that is looking at, the potential effects of Biggs killer whale predation, shaping their preference for different haul out sites?
So we actually have a grad student who's starting to look at that using the database from the Whale Museum and trying to combine that with the PFW's data, the follow-up flyovers. So we'll see how well that goes because it's very different. You know, one is like opportunistic type of data, the other one is very planned and great data. So maybe there are shifts in follow-up usage. So we'll see how that goes, but yes, that is a really interesting question. Yeah.
Just following up on that, was there any link between like reproductive cycle or mating and where the sex specific call-outs were happening? Like,
So actually, I have to admit quite shamefully that we haven't really looked at that data because you know there are popping data in your flyover. Yeah, that's part of checking things out. So certainly on the very like limited sort of correlational study, it appears that the male follows closer to marines. So certainly popping seems to might play a role. Also, we don't have much data over the winter months, and you know there are a few like anecdotal observations, for instance, from you know up in BC, the sites that we looked at later on in the year, the difference between males and females in salmon consumption actually went away. So it could be that popping constrains females to stay local and go for benefit prey. Yeah.
You want to read the question?
yes, and this is actually for you. Are there any hypotheses on why the sex ratio is skewed towards female in the North Hood Canal?
I don't know. Any ideas?
I mean, so one of the, it's tied to both of these last two questions. One impression that I have, and I'm hoping will be better backed up by data soon, is that females will pop just about anywhere. You find pups in marinas every year. But there really seem to be these big aggregations of pupping females in some of these larger, more complex estuaries. And so we captured, or even in some of the smaller estuaries for that matter, spots where they can find protected side channels in shallow spaces. And we captured 35-ish seals at the Duckbush River in the fall, and not a single one of them was an adult male. And so they were either all juveniles of either sex or adult females. And we've seen really similar, less of a skew, but we've seen a bit of a skew at Nisqually as well. And when we were working for Susan Bay at Still-Momish, really, you've been up there at low tide, it's such a massive tide flat, really protected, and those animals from our tagging data just stick to that tide flat. When the tide drops, hang out right on the edge. When it comes up, you go back in. And that was also a hugely female skewed space. So I'm really excited to get the sex data back from the scats, because that'll tell us were we just sampling poorly from captures, or are there actually some of these sex segregation, structuring the population happening in these estuaries. What we don't have are all the concurrent, other samples to show. But Northern Canal, I guess I don't know, I'm trying to think specifically what site was in there. That Port Gill net issue. Yeah, which it would be an interesting one because that is a net that is frequented pretty regularly by people, but I don't know, it'd be interesting to think about some of the site specifically, but we're describing for broad patterns.
Yeah,
I have a question. Were you gonna say something? I had a question for Liz.
oh, I was just saying a request to the fish people, we kind of think there's like a data gap in terms of fish predators on salmon. Am I assuming that right? So for instance, looking at the Atlantis model, we were just surprised that certain connections in the food web really didn't show up. And because the reason is, right, seals aren't eating only salmon, they're actually eating most of their prey is actually something else. And some of those fish are actually predators of salmon. So in order to really evaluate the total impact of these events, we really need to know those other conditions.
Did you assess different fear strategies?
Yeah, so we didn't assess like different ways of causing fear, if that's what you're getting at. I mean, there wasn't like an acoustic deterrent scenario and then a chasing them around in boats kind of a scenario. We were focused on scenarios that were tribal management, so tribal harvest with the boats mostly, or protection of gear and catch via that model regulation. So during fishing operations were the two like main fear scenarios. Yeah. But you could definitely use this framework to look at acoustic deterrent, I think. And then I guess I did have a conclusion slide that I chose not to get to, but one thing that we're really interested in using this for is looking at juveniles migrating the opposite direction through these gauntlet zones. So that would be a really cool next step to use this.
So I was at the ballot box summer. They were throwing in the firecrackers.
Yeah.
Which seems like I guess it's quite an acoustic deterrent until apparently the seals go deaf. And then just that.
That's an accurate assessment of how that works, yeah.
It does
Right, yeah.
works for moments in a really confined space, because even at F-Street, you feel the concussion or explosive going on. But do that.
They have to do that so consistently during the entire time that fish are moving through that system to have any kind of impact.
Does it not affect the fish at all? I mean, it's
Great question.
That having rubber seals sitting in the fish ladder has more of an effect on the fish than that's the bomb. But
What was it, 2 years ago, there were 6 seals concurrently in the fish ladder at one point, so I mean, regardless of where you sit on the scale, if that's a problem for salmon, they aren't that acute. Even in that space, if those fish are then hitting the barnacles on the wall and getting wounded, they're getting bacterial infections and then dying as they're going through the hot water of the ship canal. So there's other compounding issues there, but the seals are having sublethal effects with there's a little bit of salmon there too. So
that's why we were interested in doing this model in such a small spatial scale, and like there's just different dynamics happening in these really discrete areas than what's happening in the sound as a whole.
So I asked you a question before, you can tell me if this is a fair question or not, but I was wondering if you had time to think about this, your last ask. There's a pretty clear conceptual mechanism of how a seal learns from, or a sea lion learns from another sea lion, that it's a good place to go. They come back from foraging and they're fat and happy and very clearly a more robust, well-fed animal, and so maybe a juvenile or another one that's not doing as well says, that animal's doing well, I'm gonna go where he went. For the opposite, if an animal goes into the gauntlet and gets totally scared, watches another one get shot, something like that, comes back out. Have you thought about like what the mechanism is for an animal that was just out kind of foraging out in the ocean and came back and I guess they go, boy, you look freaked out. I'm not gonna go where you went. But if you thought about kind of what that mechanism is socially, how one would become negatively reinforced going in the gauntlet if they didn't experience it themselves?
Yeah, so the learning is like technically symmetrical, but we see a lot less in the model, like the learning about fear from others is not a hugely influential part of like how this is implemented. I have no idea what that mechanism would be. I also don't know that we have evidence that that mechanism happens either. And so, yeah, that is not like a huge factor in this. They're not like learning about fear, and that's how they all get scared away. Like they're all having their individual experiences.
Thank you.
And one more question? I honestly, we think that the, like you said, like carp seals are supposed to be solitary while they're out at sea. But we're finding in our area that they group up and breed, like, so I think there's more social stuff than we're giving them credit for. We just don't understand what it is, right?
Yeah, the learning about foraging opportunities, we have way more evidence to support that. Like, yeah, that for sure is happening. Again, like the mechanism is like, I'm not sure, but yeah, for sure that.
So with the new genetic panel, I think there might be enough markers in there to actually look at least close relationships, like offspring and parent relationships. So taking that together with the diet value, if there's enough value, we'll be able to get a potential learning effect.
Well, that's one of the things we've heard from tribal managers multiple times is we see the moms teaching their young to come to the Ballard Locks, for example. And that's something that's people have observed, but is not sort of widely accepted that harbor seals moms are really actively, it's like sea otters, there's a very clear, like the baby eats what mom eats, and if she's a specialist on this type of snail, baby very likely is going to at least eat a lot of those types of snails because it's costly to learn how to do something else. Whereas there's a less of that because these animals are thought to be more generalists. But certainly I think you're totally right that there's like so much more social structure and so much more, of course, they're intelligent animals that even though the mom is spending a relatively short amount of time really closely with the pup, that we don't really know what happens once they're.
Well, I think with seals, harbor seals particularly, because they're there for that month, whereas other seals, like, it's 3 days and bye, see you later, right? They have more of a time frame to learn from their mother, and then of course sea lions with them for like a year. So I think these guys do have a time to learn from their parents, and then there is some other social learning as well. And
it's happening young enough that they're observing like small pups being taught, right? So it's the timeline makes sense.
Yeah. All right, we're at time for this session, but thanks for. The food is here, however, before we kind of disperse and you can explore the grounds, eat, do what you like, we would like to take a group photo. I'm gonna hand it off to you, Don, to explain the logistics of that.
So we figure, I brought up my drone, because usually get a little bit of elevation and we do shot or so if we want to gather here by the wisteria on the green and we'll get set up and then we'll just kind of take a group shot.
And then when we come back, there are vegetarian, vegan sandwiches labeled. There are platters with other sandwiches that aren't dietary, and we did get a peanut allergy or onion. So things are labeled if you express some dietary restriction thing. So let's wrangle anyone who went to the bathroom. We'll follow Don.
Yeah.
So, hi, I'm Michael Weiss. I'm the research director. I'm the research director at the Center for Whale Research. We primarily study the southern resident killer whales here. Our main project is Orca Survey, which is an annual photo identification survey of the southern residents. We also do behavioral studies, especially interested in social and foraging behavior. So today I'm going to give kind of a really broad overview of southern resident predation on salmon, especially zooming in on their predation on Chinook salmon, as well as a little bit of information about killer whale predation on salmon predators in the Salish Sea, focusing on the big killer whales. A lot of this work is going to be aggregated from other researchers who are doing this as well, because as I'll get into, there's a lot of different organizations studying these whales and their predation on salmon. Next slide, please. So very, very basic stuff. I'm sure basically everyone in this room will know this, but just as a primer, we have two ecotypes of killer whales that are regularly in the Salish Sea here, kind of excluding the offshores, which haven't been seen in a few decades. Southern resident killer whales are listed as endangered under ESA and SARA. As of our last census last year, there were 73 individuals in the population, with basically no population growth over time, a slight decline really in the last few years, following a very steep decline a few decades ago. They are exclusively fish eating, particularly salmon. They travel in large groups. They're highly service active. And vocal. They have this very strong social structure where neither males or females disperse from their mother's group throughout their whole lives, with a few small exceptions. We also have coast transient killer whales, also called Biggs killer whales, which are listed under SARA as threatened, but have no endangered or threatened status in the U.S. There's currently more than 400 individuals in the West Coast transient population, with an annual growth of 2 to 3%, potentially slowing down over the last few years. They're marine mammal specialists and tend to travel in smaller, less active groups, and they do have a dispersal, especially females who, when they have enough of their own ring, they will often do this budding dispersal where they go off and make their own matriline. Next slide, please. Yeah, so just really brief, horribly incomplete list of the research and monitoring that go on with killer whales in the Salish Sea here. We have studies of demography for the southern residents. That's done by us here at the Center for Whale Research. Other organizations monitor the big killer whale population. Multiple organizations study behavior, the composition of their diet. There's pretty intensive health monitoring with plans to ramp that up as well. And also multiple organizations monitoring sightings, as well as doing both monitoring and enforcement around vessels with killer whales. And this is all just in the US. There's a bunch more organizations and in Canada, and a few that I've probably forgotten or didn't include here in the US. So it's a huge effort, mostly NGOs, along with state and government and federal government organizations that research and monitor these whales. So a lot of this information ends up kind of spread across a bunch of different organizations and is kind of combined on an ad hoc study-by-study basis. Next slide, please. Southern resident diet overview. This is from the most recent kind of study on diet composition in southern residents, came out last year. That used prey samples and fecal samples. In blue, we have this southeastern Alaskan killer whales compared to the southern residents. So this is kind of an overall across all their samples, but Chinook is the primary prey for southern residents, kind of followed by chum and coho, a few non-salmon in there as well. Very little sockeye, and to my knowledge, there's never been any evidence of on pink salmon. They're a little more heavy on the Chinook than the Alaskan residents, and probably a little heavier on the Chinook than the northern residents as well. So southern residents are very much relying on Chinook, but no, please. Next slide. Yeah, there we go. So that is dependent on time of year. So they're most reliant on Chinook in the spring and less reliant on it in the late fall and in the fall and the winter, where diet studies indicate they become more reliant on chum salmon. There is kind of a confound here of time of year and location. Almost all of these kind of fall samples and most of the winter samples are going to be from Puget Sound, where we think they're following chum salmon in there. And the whole population isn't always in Puget Sound, right? So this last year was mostly J-pod that was there. L's and K's were often elsewhere. So there's just a confounding here between time of year and location that is pretty hard to pick apart. Next slide. They're also pretty selective for the age of Chinook, kind of zooming in on their Chinook consumption. Killer whales, southern residents are pretty selective for age 4 and older Chinook. Probably a size selectivity effect there. Next slide. I'm going to try to stay on time. I know we're starting a little, like 5 minutes later, but I'm going to try to zoom through this. Southern residents, so this is their very broad stock groups. I'm sure the salmon biologists in the room are going to look at these broad stock groups and think of them as almost meaningless. But just to show that based on the studies we have, there's no one stock or stock group that is generally of importance to southern residents. It's very specific to the location where you're sampling. In that late fall period when they're in Puget Sound, they're primarily, when they are eating Chinook from Puget Sound rivers. When they're in the summer and spring, when they're in Juan de Fuca and the San Juan Islands, they're primarily eating Fraser River fish. And when they've been sampled on the outer coast, the majority of the samples are from Columbia River Chinook salmon. Next slide, please. And so we have pretty good evidence that southern residents are prey limited. A lot of uncertainty in the mechanistic stuff in terms of both their requirements and the content of prey. But the have is, the average southern resident needs 6 to 12 Chinook per day per whale to meet the requirements, with an estimate of anywhere from 160,000 to 220,000 Chinook consumed per year across the whole population. And we have good kind of correlative evidence of prey availability being linked to lower fecundity, increased mortality, higher circulating PCBs and other POPs. Along with that lower fecundity, lower success of actual pregnancies, and also behavior, body condition, and hunting success. So we have good correlative evidence about that these southern residents are limited by the availability of Chinook. Next slide. Actually, just to stay on time, I'm going to skip some of the hunting behavior stuff. I don't want to run over time. So if we could go, I'll just keep saying one more until the slides I actually want to hit. So one more. We'll just keep going. Unfortunately, I have to skip all my pretty drone videos. We can come back to it if we have time during the Q&A. Keep going. Keep going. This is all very interesting stuff, I promise, but I want to not go over time. One more. Okay, so just quickly a note on Biggs killer whales. The mammal-eating Biggs killer whales have become more abundant over time in the Salish Sea, with both the total number of whales, but also their presence in this area increasing. This was from a study published in 2018 by Monica Wheels and the Organ Behavior Institute, showing that the number of occurrences, which is kind of matrilines per day, has increased over these time periods, and it's continued to increase. And with that, we're obviously expecting that we'd have more predation on potential salmon predators. Next slide. So in the Salish Sea, the majority of Biggs killer whales prey are harbor seals, followed by harbor porpoise and stellar sea lions, with some of it, the next most being Dall's porpoise. They also occasionally prey on minke whales in the Salish Sea. And this is from that same study year, looking at 2017, based on sightings data. We estimated the number of Biggs killer whales in the Salish Sea, kind of, so that's in this case east of Souk on any day, and using a very simple bioenergetic model, get some rough estimates of the number of seals consumed based on their diet composition, the caloric value of the prey. And this is very much a minimum estimate, but the estimate was that at least 1,000 seals were eaten by Biggs killer whales in the Salish Sea across that 1 year of sampling as a minimum. So Biggs killer whales, as they increase, could potentially continue. So it could, as been discussed, continue to have impacts on harbor porpoise populations. So that's next slide. That's all I have. I'm very sorry that I had to skip the drone videos. If we do have time, I'd love to go back and talk about those and some of our studies of their actual behavior hunting salmon, but I wanted to make sure to get through the actual kind of ecology of it in the time we had.
Okay, thank you, Michael. I think we will try and bring those drone videos back up. But okay, I'm gonna bring up Cindy for getting your slides up. And you can use this to your slides or that's helpful.
So I'm here to support the smallest cetacean here in the Salish Sea. I like to promote harbor porpoises as much as I can, so they get forgotten, they ignored. And my work at Pacific Mammal Research is a nonprofit I founded in 2014, studies harbor porpoises and harbor seals in Burroughs Pass over in Annapolis. And we've learned a lot about them in the last 10 years. They've basically been ignored and before now. And we do photo ID, don't laugh, it can be done. I did get last when I first started saying I was doing it. But we do photo ID and behavioral data on harbor porpoises, similar to what they do with orcas, but on these smaller guys. I realized that I was thinking about this in terms of the marine mammal work group, and that everybody would know what a porpoise is. But since we have more other people here, I was just doing a quick recount that harbor porpoises are the second smallest cetacean in the world. The only thing smaller is the critically endangered rajita, so they have the moment of possibly becoming the smallest.
Just have to fix something with the screen share, so
Okay.
sorry.
That's okay. But they are, they're about 5.5 feet, 150 pounds on average. And so quite little, which is really funny when you see people go out there and be like, there's an orca. Okay, no, it's not an orca. But these guys have been, like I said, have been ignored for very many reasons over the years. And so our work is to try to figure out more about their population. And I could talk forever about porpoises, so if you want to know more, let me know. But I will focus in on now what we're talking about with salmon. So oh, there we go. Okay. So harbor porpoises generally around the world globally feed on small prey that is less than 30 centimeters. In the Salish Sea in particular, for the couple diet studies that have been done, Pacific herring, walleye, pollock, bait, and sand lance are popular. There are others as well. And you can see there, he's going after a one that might survive unless it all takes it, which probably happens. So they generally feed on these small prey. And so after sitting out for hours for the last 10 years, we started noticing some new things happening. And what we started seeing was these large fish that they were taking. And it's a very distinct behavior change from what they do when they're foraging for small forage fish. And so you'll see them under the water, kind of creating these bow waves and these circles, and you go, oh, I think they're chasing one of the fish. And sometimes you get these wonderful photos where they actually have a fish in their mouth, and they'll have a couple other ones of them there. Here you can see the tail stalk of the animal. And so we were like, that's weird. These guys can get up to 2 feet long, so I'm not sure your 5.5 foot body can eat that. It's a question. But they were taking them. We did, I'm not an ichthyologist, so we did find someone who could take a look at those pictures and identify that one as most likely as a coho. The other ones we couldn't identify because all we see is their butt, or nothing at all. So that was started in 2017. Again, it started with one person, colleague that was out taking pictures and got that one, and then we started seeing it more ourselves. So very interesting behavior that's very different than what they normally do, and to our knowledge, on the Pacific coast, salmon has never been a part of their diet. Again, there's only been 2 studies that have been done on 2-ish that have been done on diet for these guys, but you would think that salmon would have shown up if it was large part. So, our work is in Burroughs Pass, it's a land-based study site, and so we have seen it, that's not the right, presentation. This should actually have the years on there, I'm not sure why that didn't happen, that was my notes when I was going through a check, make sure that those are correct. So, I have the actual one, but it's probably too late. Anyway, so we have seen them in every year, since 2017, except for 2020, no. There was 1 year that we didn't have, it was 2018, so we've seen it every year since 2017. I'll get to this in a minute. We think it's maybe more common with reproductively active females. Remember, or I'll tell you, if you don't know, you probably don't. Female harbor porpoises can be pregnant and lactating every year of their adult life from the age of 3. Which women, yes, sounds like they are the badasses of the world, I think. So the idea is that they can catch 1 salmon, maybe they don't have to catch 200 salmons or something like that. And what we've seen is mainly they're in late summer and fall, so between August and October is when we have observed these behaviors. Obviously, what we're observing is probably much less than what is actually happening. We see that a couple times a season. But we did actually just recently see one in May, one of our poster child porpoise, her name is Pointer. We've seen her over 130 times in the last 8 years. She was hunting a large fish in May, which I'll show you in a second. Interestingly, we were out a bit outside of our area doing some eDNA work, and we saw a bunch of attempts on harbor porpoises going after these large fish. Again, most likely these are salmon. I think when we talked to the other fish guy, he's like, that's the shape of that fish is the only type that it would be in our area, right? So it's not anything else but salmon, just what species, not sure. But I believe, this is all salmon people here, you can tell me if I'm wrong. I think it was a coho run in fall of 2024. And that was when it was September when we saw them just going after them. So I don't know if it's just coho they like or it was not. So here, this is actually, I think this is probably actually Pointer. She does have a fish, it's kind of hard to see there, and this is another indication of the different type of surface chasing that you'll see when it happens. So the next one is a drone video. It's a short one. Oh, wait, sorry. See, I forgot I was in charge. You can hit play, probably be easier for you to do. So this is Pointer, and that is a salmon. And you see she has it crosswise in her mouth. This is some recent drone work that we did. And they generally seem to dive down to then eat it. And what's interesting is that they do have to swallow it head first. And so it takes extra prey handling for them to grab it, and they almost always do it like a dog bone, and then take it down and then somehow orient it and swallow it, which is interesting. So she is a female. She has a 10-month-old calf named Lee, because I like Garfield, and that's the tiger, Garfield. And I think she might be pregnant. She looks really big, so we'll find out if I'm correct. But so again, a reproductively active female that is going after these large fish. So some other animals have decided that this is an interesting behavior that they could partake in as well. We see gulls going after small fish all the time. Oh shoot! There is one. The only other time that we've seen salmon in the harbor porpoise diet is recently in 2019, where they found pit tags of juvenile Chinook in stranded harbor porpoises on the coast. So there is another indication of some level of salmon predation for these guys. And that is zip line, I believe, again with a giant fish. So the other animals that are partaking in this are bald eagles. So they're very known kleptoparasites. They love to steal things from other animals, but not really other mammals except for river otters. And so we started seeing this in 2019, about 2 years after we started seeing them take large salmon, the porpoises taking salmon. And you can see here is the fish, and the eagle's probably about 2 feet above that porpoise. And so I was watching this large fish be eager, and then saw him come down and like, you literally just stole that fish from that porpoise. You're so rude. There's a reason why Ben Franklin wanted the turkey and not the bald eagle, as the nation's say. And that should be illustrated all 2020, not question marks, but again, I was thinking the wrong file, gosh dang it. So the other thing I wanted to mention, since I have a captive audience of salmon people, is when we started looking into the fact that they're eating these large fish, my first question was, are you going to choke on that? Because it looks like you should choke on that. Long story short, they can. And so we looked in the stranding network and asked a lot of questions. And there were 27 different cases of them asphyxiating on these large fish that had never been put in the literature, which is really weird, because usually if something weird like that happens, someone writes a note. But it's just an indication of how much porpoises have been in the background. So what we found is that the majority of those fish are American shad. And this is from the Golden Gate Bridge, their stationary drone that they have out there. And so they were seeing these large fish cases as well. This is from the same paper as the large fish paper showing the salmon here. So the American shad are on the outer coast and in California. And what we found is that up to 87% of the animals, 92% were females, and up to 87% of those were reproductively active females. So really, it looks like it's an indication that it's females that are going after these large fish, which could be a problem for the population if it gets to a bigger load, because now you're losing potentially the mother, the fetus, and the dependent calf, possibly. So what I wanted to bring up to the salmon people here, which I have not found an answer to, but in the Columbia, as far as I understand it from some of the data, this invasive introduced species outnumbers salmon, all the salmon combined. And I feel like nobody is talking about them as an issue for salmon recovery. And I'm hoping if other people don't know about this, that you now know, and you take the mantle or something. I've been trying to tell as many people as possible that it just boggles my mind that that's not, and also something that's being considered. And maybe it is, and I just don't know about it. But it's another issue. So I like this little eyes too big for their stomach type thing for the porpoises. But anyway, that's what I have about the porpoises eating salmon. Again, it's not a whole lot that we know of, but it's probably more than we can observe just based on the suffering.
Thank you. Since we experienced some technical difficulties and started a little late, we'll go for another like 7-ish minutes for questions. Any questions for Cindy or Michael?
There's a newish paper, I think it's 2024, Approximate wrote about we had and a lot of the competition between salmon and shad. There's a couple others too that I can't quite remember, but it was in a sea lion predation. It popped up along the coast as well, so it became of interest.
Okay.
So there it is known.
It is becoming more.
Yeah. Becoming more now.
That's good.
And I'm sure people.
And it's upstream farther too for the Columbia Lake Water. People look on a bone shaft and you see some papers that come out about salmon and stuff like that.
Okay.
Still applicable, big portions of that are applicable.
Yeah, okay, good. I just was like, I just generally.
Yeah,
that's why.
The first time we saw it in our data, we were like, is that even like, is there an error in the data? What's going on? What's happening? Yeah.
Well, and I even talked to somebody at WAW that I was like, it's not labeled as an invasive species, it's labeled as a recreational species, and I'm like, that is so wrong.
Straight up on the Buca now, like,
Okay.
you know,
Yeah.
over triggers, and then we see interactions with them in the porpoise there in the straits also.
You do.
Right, and
That's
that's the pictures of the guy on the scanner caught a shad.
Yeah, yeah, so it becomes like impulses in pretty big numbers, shad and sardines on certain years, and I can tell you what the predictors are, but then we also, there's like 300 porpoise in the straits right there that we see all the time and there, we see them now.
I would love to talk to you more about that, because we don't see in our data, it's only salmon here, 'cause we have not seen shad, the shad are now starting to come in here.
Yeah,
I problem, and I don't want pointer to die.
5 years worth of shad data in the straits for porpoise.
Wow, interesting, well, that's interesting, yeah, okay, cause it's, yeah, it's the shad that they're choking on, not the salmon.
So without talking with some Dr. West, like Michael and his progenitor at the center, Ken Dockham and John Ford, they said that one of the reasons the killer whales made prey share is that the fish are too big for them to eat individually. If that were true for the killer whales, it would gotta be true for these animals. So do you see prey sharing?
No, they can't, their teeth are this big,
Well,
like literally, like I don't think that they can actually rip it apart. Yeah,
not
it's,
like the seals, I can't go up and do that.
we have never seen them do that, like, we see the seals and the sea lions flapping them up quite a bit, but, that's not in their behavior.
Right.
I don't know if they have the, nebula to do that either, but from what we understand, looking at, like, their teeth are literally this small.
Because I almost always see them from our boat as one or two, or maybe, is that three? No, I think it's two.
Right.
We don't see, them hanging out a lot in order to grab a part of the fish.
Yeah, I mean, we see them in large groupings, their large groupings of harbor porpoises are much more common than previously thought. So for example, in 2022 alone, there were 160 aggregations of 24. So they do group up, but I think they're going after, it's probably foraging to a large degree and also social, but I think they're probably going to the smaller fish there, not the large ones, yeah.
It seems like from the size of your teeth that there's something wrong with it, that actually traditional juvenile salmon might be a larger impact, but it sounded like there was limited diet studies.
It's not in there, so there, salmon is in Atlantic harbor porpoises, salmon species are in that diet, but not in the Pacific as far as we know.
But only two stems.
Yes, Nichols and another one that I know of that are like the diet studies that cover California, Oregon, Washington. But then there's the Duffield one that showed pit tags of juvenile shad in there, so there hasn't been a more recent analysis of diet.
I mean, I guess they're probably mostly concentrated on large pool fish.
Well, I mean, we just captured drone footage of like probably a 30-foot bait ball herring, and the porpoises were just zooming through them. So, yeah, so much to learn about them.
Other questions? Yeah.
Michael, can you hear me?
I can hear you a little bit. I might need to have it. It's kind of coming in and out, but yeah, go ahead.
Well, I'll type it if I can't, if you can't hear me, but, I'm wondering about California sea lions as opposed to stellar sea lions as prey items for pigs, and, I think I saw in Monica's plot that the stellars were listed, but I'm just wondering, how often do you think California sea lions are taken, by pigs versus stellars?
Yeah, that's a good question. I am not sure in the Salish Sea because I don't know how much of the observations of Biggs killer whales hunting have, occurred further south down in Puget Sound and along the coast where you might get more Californians as opposed to, out here in the San Juan, the stellars just outnumber them so much that, almost all the sea lions out here are stellars. I'm trying to remember what I know about Biggs killer whale predation further out. There's kind of two subpopulations of Biggs killer whales. They're kind of inner coast Biggs killer whales on the west coast that we see mostly here. There's kind of an subpopulation. They're not totally separate. They do intermix. But I would expect that California sea lions will be a larger portion of the diet for those outer coast whales. But yeah, certainly here, where I actually, study pigs and observe them. We just don't have that many California sea lions out here. So I've not seen a big's predation on California sea lions, but I'm assuming it'd be opportunistic, right? I don't think they'd have any huge reason to prefer California sea lions other than they're just bigger animals. But being bigger animals also makes them more dangerous to hunt too. So I think there's no reason to think they're not a major prey item for bigs in the areas where they significantly overlap with them.
I wanted to say one more thing before, since you talk about pinheads, just in our study area in Burroughs, we see Stellas and California ceiling, come through in fall and spring. They will come through the Burroughs Pass, periodically, or really distinctly. So actually a couple weeks ago, they started like, oh, must be springtime. They're starting to swim through, so fun sightings.
One more question, time for one more question.
Your burning desires about harbor foxes.
Yes.
So the question for Michael, are there any data or just anecdotal observations on non-consumptive effects of the big killer whales, like seal behavior or sea lion behavior?
Yeah, really good question. So in terms of studies, I think it's fairly sparse to my knowledge on published studies. I know that there are published studies indicating that harbor seals can tell the difference between the calls of fish-eating and mammal-eating whales and will respond differently to those calls. So they know the difference. But in terms of, larger scale changes in kind of the distribution and behavior of seals, I don't know of any good data on that. Big killer whales move around so much in a given day, and they switch up, the haul outs they're visiting so much every given day. It's pretty rare to see, the same matriline spending time in the same small area, visiting the same haul outs multiple days in a row. Although that does happen. So I wouldn't be surprised if there's not a huge effect of Big's killer whales on kind of the haul out locations of pinniped prey, where the time, just because actually, at least out here, it's pretty hard to predict if you're a seal where you're going to be at the biggest risk of Big's predation. There's nowhere is safe, essentially. So yeah, but it would be I would be really interested in hearing any and seeing studies on that. I don't know of any off the top of my head.
I kind of think that maybe Burroughs Pass is somewhat of a safe spot, maybe why the seals and the porpoises are both there, because we do occasionally see orcas come through, but fairly sparsely. Whether that's true at all, I don't know, but and sometimes we'll see like, oh, the killer whales are just there, and then porpoises show up like a minute later, I'm like, what are you doing? So I don't know what's going on.
All right. Well, thank you, Cindy. Thank you, Mike.
So next is going to be Liz Duffy, who is Salmon Science Project Manager from Longwood King. And was part of the Sailor Sea Marine Survival Project, and so it's going to kind of give us a little bit of history and a little bit of context and wrapping the whales to the salmon, all those work to be. They thought we didn't be here, but they're not. As Don said, I'm the Associate Director of Science at Longwood Kings. I've been at Longwood Kings for about 3.5 years, and actually started after we officially sort of wrapped up the Salmon Sea Survival Project. So just as a caveat, I'm presenting on findings of studies that happened, well, I wasn't technically there. So if I make mistakes about people's work, blame me, not them. Just trying to summarize, the Sailor Sea Marine Survival Project, if you don't know about it, was a transboundary, huge international research project between British Columbia and Washington, co-led by Longwood Kings and Pacific Salmon Foundation. And it was really centered around one big question of why is marine mortality so high for co-ocean and steelhead in the Sailor Sea. And it was started around
2012 with discussions, but the bulk of the work happened between 2014 and 2019, with the big reports wrapped up in 2021. And one of the main findings was that predation was one of the big causes of this high marine mortality in the Salish Sea, and so that's what I'm going to focus on. And most of that predation work centered around pinniped predation, so I won't be able to wrap up everything around harbor porpoises and whales, but I will largely focus on the work that was around pinnipeds. And as I said, a lot of this work was done by other people, primarily Megan Moore, Barry Berjikian, and Mike Malley at NOAA, Ben Nelson, who was briefly at NOAA along with the Kings when he did his work, Matt Bumble, Austin Thomas, and they contributed some of the slides, some of the content that I'll be showing. So I think we've heard this earlier today. Casey Clark gave a good overview of abundances, but due to the Marine Mammal Protection Act, harbor seals have been at low numbers in the 1970s before that section came into place, and experienced a rapid increase in the Salish Sea from the strait of Georgia from about 5,000 to about 40,000. And Puget Sound from about less than 1,000 to about 20,000. I think Casey's numbers from 2023 from this morning put it about still at 20,000 in Puget Sound. And so, and largely since the late 1990s, those numbers have been more or less the same, indicating that maybe they're at some carrying capacity. And that corresponded in that same sort of 1970s to late 1990s with declines in Chinook, Coho, and Steelhead in the Salish Sea, and also sort of a plateauing of marine survival rates at a low level since then. And marine survival for those species of salmon and steelhead have remained low, despite other management actions like harvest reductions. So if we look at what marine mammals are doing in terms of predation on salmon, a lot of the estimates have been made with using tools like bioenergetics models, and Brandon Chasko and others put together consumption estimates by 4 marine mammal predators: harbor seals, stellar sea lions, California sea lions or Californians, and that was between 1970 and 2015, and they made estimates in terms of those numbers. Oh, that's what I wanted to do, sorry. Numbers, which is that graph on the figure on the left, and biomass in metric tons, and they broke it out seasonally. I'm just showing you the spring panel, that's when the juvenile salmon are migrating largely. And what you see is that, at least in terms of numbers, harbor seals were the main predator numerically, and that's because they're eating kind of relatively smaller salmon, so they eat more of them. And you can see the big increase between 1970 and the 1990s as their numbers increase. That's kind of leveled off. And by biomass, orcas, obviously being larger ones, eat a lot more, they have a lot more body weight to support. So they actually make up most of the biomass of Chinook, and they also eat larger adult Chinook. But we also see that increase due to harbor seals in terms of the biomass of salmon that are being eaten, and then that's kind of plateaued. So in the Salish Sea Marine Survival Project, since we are focused on juvenile salmon and in that portion of the marine survival, researchers really honed in on a few key questions. First of all, we're looking at impacts on juvenile salmonids versus adults. They also looked at expanding research to include besides looking at Chinook, also looking at impacts on Coho and Steelhead. Looking at using novel techniques, which maybe aren't so novel anymore. People have mentioned that in other talks today, like DNA method barcoding, and then investigating strategies to how we might reduce the predation impact. So here's one example of a study that happened, again, using bioenergetics models to come up with consumption estimates. This was done by Ben Nelson as part of his dissertation, and the map on the left will show you whether I'm talking about Strait of Georgia, which is right now it's highlighted in blue, or Puget Sound, that would be highlighted in blue down there, or all of the Salish Sea. So just, that's what that panel on the left is. But what you see is he was estimating based on diets of seals in the Strait of Georgia, looking at, both the instantaneous mortality of how many Chinook are being eaten in coho versus coho, and then the proportion of, say, a juvenile salmon run that's being eaten. And this is on the x-axis you see here. So, as we've learned in other talks, even though salmonids make up only a small portion of the diet of seals in general, what they eat herring, they take more as a preferred food, that they can actually make a big dent on Chinook and coho salmon as they're out migrating. So that's about less than 10% on an individual basis, but when you look at the proportion of the run based on how many seals are actually eating them, 40,000 seals, they can eat something like an estimated 40% of that out migrating run of Chinook and about 54% of coho. And that's because there's so many of them. And just a caveat, in a lot of these studies that use bioenergetics modeling, a lot goes into the assumptions that are going into how these estimates of consumption and population mortality are being made. So just wanted to take a pause to talk about that. And so we talk about, first of all, we need to know the diet data. And people have talked about diet data largely from SCAT. So depending on your temporal and spatial resolution of how often you're sampling your SCAT diet, that will affect how accurate your diet data is. You can use like new techniques like DNA metabarcoding to get more accurate identifications, and you can use bones to actually reconstruct sizes, which is important because you can know that you're eating a certain species of salmon, but the size of it will make large differences on your total population estimate if you expand it out. So a lot of that work was done, and then predator abundances. So we're saying it really matters if salmon are only a small part of your diet, but then you're saying, you know, are there 10,000 seals eating? Are there 40,000 seals eating? Because that will really impact what we're saying, that their impact is. And so what they used was haul out estimates. It was correct to have that correction for the seals that are not out of the water, that are under the water. And I think Casey talked about that. So again, that's one thing that you have to know how they're calculating that. And then when we're talking about the population impact on juvenile salmon, we're using data that I think Mila and Chris talked about this morning. Juvenile, they didn't really go into the juvenile, how we estimate juvenile abundances, but we use data from small traps typically, so you get a count of small salmon leaving rivers. And that, you know, we're basically assuming the count and the accuracy of that count is what we're basing our percentage of the population impact that we get. But sometimes there's errors to that. Sometimes there's mortality that happens between the small trap and when we might get to that spot in Puget Sound where they're encountering them now. So those are just some caveats as you interpret these data. So, in putting that into practice, here was another study that Ben Nelson did later. So again, this is in Puget Sound now, and we looked at seals eating Chinook in the top panel and coho. And this was done in 2016 to 2018. And when they used their estimates of diets and they expanded out and they used sizes of salmon that were catching near shore, they got, I don't know if you can see it, but they got these purple dots, the higher dots. They have calculated a higher level of predation than when they looked at that, recalculated the size of the because they're eating based on the bones found in the diet. They actually figured out that the seals were targeting larger salmon than what they were catching near shore of the environment. So that really impacted their estimates of the population impact, and it was lower than they thought. So that's just one way to think about these things. And in Puget Sound, there was less impact on Chinook and coho than in Strait of Georgia, about 10% mortality. Now we're going to switch to steelhead. These are some really cool studies that Megan Moore and Barry Verdikian did. And this is Puget Sound, and those dots that you see on the map are arrays that pick up acoustic tags at major river mouths and sort of migration points from Puget Sound out to the Strait of Juan. And they put tags in steelhead, and what they found is that steelhead migrate very rapidly within about 2 weeks once they leave rivers, and they're like heading out of Puget Sound. Unlike other salmon, But during that time, they were experiencing really high mortality, like 60 to 94% mortality in this 2-week period. All right, so these are some arrows. So like this is showing like takes about 3 or 4 days to river mouths. And then they hit the color of the arrow shows the intensity of mortality. Green is like, oh, no, not a lot. Red is a lot. Yellow is kind of like stuff like medium. So they hit some bottlenecks of mortality as they leave. So even this 60 to 94% mortality is mainly happening at these bottleneck spots. I guess like kind of like the gauntlets that Liz was talking about. And yeah, so a lot of these are river mouths or infrastructure spots that make pinch points. And so one of those pinch points was in the Canal Bridge, and using tags and to calculate the mortality, they were getting this from tags that were recovered near haul outs, so that, you know, documented predation events. They were finding that about 50% of the juvenile steelhead leaving the canal died at the bridge. About 50% weren't making them out and they were dying at the bridge, and that's largely due to how the bridge is built. It has these 15-foot pontoons, and steelhead are very surface-oriented migrators, so that for them, they're like at the surface, and if they hit a wall, and they have to try to find a way around it, and seals, that's really easy for them to then dive in and eat them. And then we also talked about Nisqually, the Nisqually River mouth being an area where seals aggregate. I think Casey talked about a barge, so there's a lot of seals and sea lions that hang out there. And they did 2 different comparative studies. They did a consumption model estimate, and they also did an individual estimate where they tagged steelhead, not just with a acoustic tag, but one that also reported temperature. So they could tell by the behavior of the tag, did it look like a fish? Was it heading straight out? Did it look like a seal? Was it going up and back the river mouth? And did the temperature go up from like a full-blooded fish to a marine mammal's stomach that showed that it had been eaten? And so they kind of got more fine resolution data, and they found that at the Nisqually River mouth, they were getting similar estimates between that specific tag data than from their consumption model, and about 9 to 33% of those steelhead were being eaten within just those 3 or 4 days that they were migrating out of the Nisqually River mouth. What's interesting to note for salmon in particular is, like we talked about, salmon are usually a sort of specialized part of their diet. They mainly eat forage fish, and mainly eat hake. I don't know if I said that right. Seals mainly eat forage and hake. Okay, so this shows somebody talked about blob and ecosystem effects. And so in blob piers, there's a lot of anchovy that came in. They're more of a warm water species. And this shows the sort of, let's think about the abundance of anchovies on the x-axis, and then the mortality rate of steelhead in Nisqually. And when there's, basically it shows that when there's more anchovy or other forage fish, less steelhead get eaten. So it really shows that it's really important to have these healthy populations of forage fish and the main drivers of all of our food web, and that will help reduce the predation on salmon. In addition to, like, we don't just have to scare the seals away, we have a lot of other good feed for them to eat. That's another way we can help salmon. So there's, I don't think I'm running out of time, but there's a lot of, those are the main findings. Harbor seals were found to have a negative impact on juvenile salmon survival. It sort of depended on how many they were and largely these bottlenecks. There's more responsible for mortality on juvenile coho, Chinook in the Strait of Georgia, and more on steelhead and Puget Sound. We talked about hotspots, migration barriers, and then, but when you try to expand individual studies of marine mammal predation up to population level impacts, it's very sensitive to the assumptions that you make, so you have to make sure you're thinking through those. And yeah, really important to have healthy forage fish, which is another plug that I'll make for the forage fish and for the forage food. And then another side of that was recommendations, and it's nice to see a lot of the work that's been coming out and being continued on since then, because a lot of that's been based on recommendations. And one of them is investigate approaches to how do we reduce predation. And I think the gauntlet study Liz is doing is an example, like how do we use predator deterrence, fear-based deterrence, removals? How do we support recovery of forage fish populations? How do we facilitate passage at these hotspots? And should we perform experimental removals or some combination? And then, do we need to improve more understanding a little bit about not only pinniped, but other marine mammal predation on salmon? So, these are some other questions, like, does climate change impact that? What about our big killer whales? Can they be a fear-based deterrent, you know? Do hatchery fish change the scenario by either attracting predators or being a predator buffer, like healthy forage fish? Or things like that. These were all partners, we had a lot of partners, it was a huge study. If you want to learn more about it, go to the website, there's reports, there's presentations, ask some questions or email me and I'll refer you to the experts that you want.
We have five-ish minutes for questions for Liz, and then this opens up to our group discussion as well and some reflection time, but did you have a specific, sorry, you were up here, so I was.
No, I'm okay, here's. Despite everything wrong with every.
So questions for Liz?
So it's, you know, I've seen the graphs again of like MMPA, harvesters go up, and then at the same time, the fish went down. But is that taking into consideration everything else that's going on? Like, there's a lot of other stuff going on at that time, including humans taking an ass ton of fish, pardon my French. But this is something I feel very strongly about, where we're all talking about what pinnipeds are doing, what herbivores are doing, what killer whales are doing. Why are we talking about what people are doing? We're hunting endangered fish. So I was just wondering if in those categorizations of that, how all that other stuff was taken into consideration, because it's not just a direct correlation that harvest will not man down, right?
Yeah, so I will borrow from what many people say, or what I heard Brian Beckman say, it's a correlation and not causation, right? So, that we were looking at things happening during this timeline that were co-occurring, right? And so when you look at predation, that's part of the story, but the main, you know, that was what I was focused on today, but one of the main, things we say about marine survival projects was there was no smoking gun. Like, food supply was a big, you know, rose to the top in the hypotheses, and predation rose to the top. And again, I didn't include fish predators, I didn't include bird predators, I didn't include other things. But a lot of the other things that were known to have contributing impacts were like contaminants, toxins, water quality, other things. So disease, climate change was sort of overarching and making everything worse. So I wouldn't say that this was like, you know, the main reason that we were seeing these things, but it was a notable increase, maybe to healthy levels. And when we used to have healthy levels of salmon, that level of top predator wasn't making as big of a difference. So we did look at a lot of other things.
Yeah, no, and I figured it's just, especially right now, the climate of, let's just go kill all the seals and sea lions, because they're the problem. I find sometimes that correlation can just be made causation, and I don't think it's fair. And I'm not saying that you did, I'm just saying, just in the general political terms of things that's happening, I think it's important to just emphasize.
That may be more a messaging thing, because it's really hard to, as we know in current communication climates, to get out all of the information. Everybody wants us to simplify the messaging down to. Right, well, it's not even just that, it's that we've known about shad, basically, but we're not talking about that at the same time as we're talking about these other things. And so it's just a matter of like where you sit in the lens you're hearing things with, and so it's just really hard, and almost probably impossible to measure, to communicate a complexity of these systems, you know, and so it's like, yeah, we know that the harvest is an issue, we know that climate, and we know that I've heard, I think Alan has talked about, Alan has talked about the fact that, you know, there was a lot of fish in the 19th, and maybe there was a very large, not overpopulation, I'll never say that about fish, but maybe there was a bit of a bubble before 1970 that we measured that was part of a decadal oscillation that we're not sure about. So just trying to communicate that all of this and without people going, oh, no, blah, 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 blah.
No, sure, I totally get that.
Yeah.
It sometimes seems that the benefits get the short end of the stick, just in where things are.
Yeah, and I mean, one of our biggest problems is when we talk about the chum salmon doing so great and the public hears, yay, we've done it, we've recovered fish. That's like the biggest miscommunication, and so that, if we can conquer that, maybe we're start on this whole predation thing, yeah.
No, it's super complicated.
I think one thing that did stand out, say, is like where humans and the ecosystem have intersected in a bad way, like, or like, you know, where infrastructure, or like lockdowns in the state of Georgia, or.
But we're creating these
places
places
that
that
they
they can opportunistically,
Yeah.
or punishing them for taking that opportunistic thing of making it easier for them to eat, like, seems unfair.
And those are places maybe we can look for solutions, because we've helped cause that problem.
Yeah. No, agreed.
Keep that in mind when we start talking to now the new one about pink salmon may be causing problems for Chinook. And my question is, maybe the pinks are just able to take advantage because we don't have Chinook, so maybe they're not the problem, they're just taking advantage of it, I don't know. But so it's, again, communication.
And Cindy, you were saying pinnipeds are the scapegoat in these systems, but fisheries are being reduced. Right, so the only action that's happening is a reduction of fisheries. The talk, people are saying, I'm frustrated with pinnipeds, but the fisheries are being reduced, and so livelihoods and connectivities of cultures and those side of it aren't being affected. And I think sometimes that part of the conversation gets lost too, that those fisheries are declining. And if you look at that back from the 70s with the passage of Marine Mammal Protection Act, those fisheries have declined as those marine mammal populations have increased.
Yeah, I do, you know, think that for sure, but like, name another species that's endangered that we are still allowed to fish or hunt. Like, I don't know of any others, right? Why is that allowed? Why isn't it moratorium until we can get our populations back? I understand that there's a whole lot of political and cultural and livelihoods that go into that, and you can't, I guess I'm not saying that's not easy, that's my answer, but like, well, that's a question.
There is somewhat an answer to it in the context that we have the treaties of the law of land and the tribes of fish. And salmon come back and they die. So what you're doing at one point is you're through the management is you're just killing some of them for the spawning ground. So you can balance that out with harvest. So we do spend a lot of effort, and some people would probably say we don't cut it down enough. But there's a lot of effort to look at the exploitation rate with respect to recovery. So we'll have an exploitation rate that will still allow recovery.
Right. No, I think that's perfectly, I think it can be done, I think it's just. Yeah.
Yeah.
There's a lot.
I might also add, like, I think the key perspective as well, in Tom mentioned, is that without harvest, you're not gonna have hatchery fish. You're not gonna have hatchery production. Those programs are in place to support harvest opportunity as well as conservation and restoration activities. Without harvest opportunity, those programs go away. We look at pretty much any stock and crude curve for any population of Chinook salmon in the Puget Sound. Without hatchery fish, they're gone. They go extinct. So I hear your point, but I also think the reason that they are still maintained is because they're at harvest, because the state and the tribes prioritize production to support that harvest, and without that, most of these populations will go extinct. And some are gonna go extinct, regardless.
I wonder, Kevin, if there is, I wonder if there is a avenue here with the vital signs and indicators that we can also incorporate and maybe do better jobs of connecting with the good things that we're already doing for fish, you know, and for salmon recovery and whales and other things. So it's so that people aren't thinking we're just killing with pinnipeds or proposing to kill with pinnipeds, and that we do highlight the incredible reduction that the tribes have had to endure for their harvest. Now they're not being able to fish historically like they used to. Because everybody thinks, you know, everybody's out there fishing. And then historically that is not, you know, it's not the case. And then what we're doing as far as how we're handling 6 PPD clean out, and we're incorporating those regulations and the stormwater, and road, watchdog projects. And so maybe we can do a different job or a better job at doing that for the vital signs. That seems like it would be great role for PSP and something that we can do in our work groups, so we can help message that out too. Yeah.
I think fisheries in general, we just have Washington have decreased. I mean, treaty fisheries have significantly decreased, but I would say the last 5 to 10 years, even the PFW sport fisheries have been highly constrained over the last 4 or 5 years.
Yeah.
And from sort of footprints that were year round in marine areas to weeks, maybe, yeah.
Yeah,
So,
that's a good point. Chris.
I know I'm probably stepping beyond where I should be as a commission and saying that, but yes, the tribes have still reduced fishing opportunity, but as the recreational side as well.
Yeah, that's a really good point, because we hear that from the Santa Cruz Council. They show up sport fishing guys, the anglers and everything, and they're like, and they've had to take it on those too. John, you were gonna.
Well, I was just gonna note that we should even think broadly about what's going on. So in California, they haven't had a Chinook fishery in 3 years. I mean, the whole industry may collapse this year.
Wow.
And so we have our regional issues, and we got our big regional issues. Our Pacific Wide Coast and Chinook are coming back. You know, I mean, they haven't had some good years when you think they would have. So there's something else going on.
Which kind of leads us to our questions that we were thinking.
I think
A little bit,
so.
yeah.
So, thank you. Liz. I think discussing this is kind of going into our next agenda item, which is open discussion and group reflection. Reflecting on the presentations from today collectively, but also speaking to any questions or concerns that are rising to the surface as you're hearing these questions and presentations coming up. So we were hoping to reserve some time, and I know this room isn't set up great for group discussion, but bear with us if we can pivot. To just talk about shared data needs, potential gaps, areas for further collaboration to answer some of the needs or gaps that are being identified in your mind. And consider opportunities to coordinate with other working groups. So how to plug for forage, fish and food webs, which we've coordinated with in the past. But just as you're thinking kind of the reflecting on today's presentations, is anything coming to mind about gaps or data needs that would be beneficial across different focus areas?
And I reached the 21 thingies in the chat.
Yeah.
I trust in the campus.
So hopefully folks online heard me, but I'll start off with these guys, yeah.
Like, sort of have a question for the whole Salmonids work group, which may build frame what I think is a big data gap. So for the returning adults, across all of the different species and the different runs, do the adults eat on their way as they swim through the marine environment and or on their way up the rivers? General question.
Who wants to answer?
Once they get to the river, they don't.
Yeah.
Okay, so not in the river.
Unless you're stealing.
Well, there you go.
Right.
River game.
Which makes the whole run to Idaho pretty epic. Chinook built, I can't remember how many hundreds of miles they do upstream through and how many dams, and they're not eating, which is pretty amazing. Yeah.
Okay, so there's in-river successful fishing with lures, so that
Yeah.
they're biting, but they're not necessarily eating natural.
Yeah.
Right?
Great.
Okay, it's interesting.
Yeah, nice angry.
Okay, and so the second part of the question is, it's implicitly, maybe they're eating some things in the marine environment?
They're eating.
On the way back to
I think coho grow a lot in that marine phase when they get into Washington waters, and when they enter our fishery for macaw fisheries, they're really small, and you know, our fishermen try to avoid them because they target them. So that they're more available to catch that quota at the end of the year when they've grown, or end of that couple month season, and so those fish are growing quite a bit, even just a couple months growing season. The value for fisheries, you know, goes up a lot, just in, because of the growth of those fish. Right.
Okay, so for some species, for sure, they're
And they're, you know, just sport fishing, you catch them, you open them up, they're definitely full stomachs. Yeah. So, yeah, you see it.
Just generically, what are they eating?
Krill and bait fish and. Yeah, I mean, that's the general, right? Yeah, there's some cool studies out of UVic on like winter diet and such, but I think during the summer, fall, when they're coming in, I think what you're talking about, most of bait fish and krill.
Okay, well, I guess the data gap, this is harkening back to work I did with Anna a long time ago, the first time I met a real salmon scientist.
Me too.
Using acoustics to track, you know, with active tags to track movements within the marine environment. So I think that's the big data gap I want to identify. It's like the marine distribution of salmonids in Puget Sound as they're preparing to go up the rivers is very important to the sort of residents, for example, and probably most salmon or porpoise predators. So that's the big one. And I guess I didn't force you to like tell me for sure, like how close to the ocean do you count? Like what's the best estimate of marine arrival of a run into a river? And we use things like the Albion test fishery on the Fraser or the Bonneville counts, which are way upriver, but they're still a proxy for what came through the marine environment. So looking, speaking as an oceanographer, like one way I think of filling that data gap is to use our oceanographic models, which are very good at now forecasting out a few days to predict what's going to happen at the phytoplankton and the zooplankton level, and then on top of that, model like where are herring or where are euphausids, and sort of beginning to build, you know, predictive habitat maps for particular prey items of marine mammals and birds. I think it's like it's an open opportunity there for the modeling part of PSEMP, but it might inform, you know, you might get out of that modeling effort more information than we currently have about the marine distribution of fish from actual direct measurements. It's not saying we shouldn't do more, but maybe we should go back to doing more active acoustic tagging or hydroacoustic surveys, trawling. Which I think maybe the Canadians do better than us, including recent Andrew Trace's his students' recent hydroacoustic surveys that have gone this distribution question. But that's the big data that I see. I've missed something you all said today.
I would say some of that modeling too, not just trying to guess where the salmon are, but understanding the forage fish populations. So like out on the strait, there are virtually no salmon spawning sites documented despite a lot of looking at. There's huge shoals of salmons, right? And in the Salmon, we have huge shoals of juvenile herring. Herring spawning populations are like tiny in one place, right? So we don't have a good understanding. This is CMC-wide, certainly across the border. Of those forage fish populations, so we're not doing a great job managing them because we don't know where they're coming from, where they go, anything past their spawning. So that same data can be used for the links.
I think a data gap with the salmon side is what portion of the runs of different salmon are staying resident in Puget Sound. Like the resident behavior is, you know, if we're thinking of the ecology of Puget Sound and health of Puget Sound, how are those fish doing? How are their behavior patterns shifting through time? Who are their predators? You know, the wintertime off Washington is when stellar sea lions have the highest consumption of salmon. It's not during when the salmon are migrating back through. They're hunting the resident fish that are feeding in that area. And I'm not sure. I don't know what they're seeing in Puget Sound with the harbor sales and such. There's also a hit on the winter time, but those are a different portion of the population, and I think understanding that dynamic is going to be an important one because you know, the southern resident killer whales used to spend more of their time in Puget Sound. And so it could be an effect on that portion of that population is seeing changes.
Is that work that we did with the Blackmouth residency and general feeding contest with Scott and I were along. That's an older work now. I wonder as the populations change and recover, starting to recover, hopefully if we have to redo it. And to see.
The surgeons were right, the data mining was for it.
But yeah, but I wonder if the data, like, I don't know, if it's considered a gap. Because we've already, that's already been published in that whole team, but I wonder if it has to be repeated just to see changes through time.
Yeah, well, I kind of wonder, and it might be a gap in my brain, it's not things that I've read versus what's in the literature, because I'm not as focused on the work. But like, we're some of that resident behavior influenced by some of the hatchery practices.
Absolutely.
Yeah, so there's that change, those hatchery practices that.
Yeah, there's definitely, so there's like 3 or 4 papers for Tom and Love, and if you Google my last name, I come up with a long-term results and not a couple, but yeah, I mean, there's a clear hatchery pattern that has changed some of the behavior, but 25% of the fish were assumed to be mushroom for Chinook. And what's interesting is you're seeing similar like behaviors in coho and chum and some of the other ones that wouldn't necessarily have, well, wouldn't have been as impacted by hatchery practice.
You would have residency of the shaman saver. Because one of the things I found weird when analyzing sea lion data off the outer coast was seeing some species of salmon at times when I didn't think they should be around.
Yeah.
You know, like you guys brought up this, the Homish has an even year pink salmon runs. And I was finding pink salmon.
We get pink salmon.
I'm like, what's going on with that being in the sea lion diet in a year when they shouldn't be in the ecosystem?
Yeah.
But they are.
And we also saw some other life history patterns that we did study that would be interesting for this sort of question. Like we saw some salmon that would not residents and they're not migrators. They would go out to the outer coast and mill around for 6 months and come back and then do it again and then do it again. And like repeat that seasonally through years. And so that's like a really interesting survival approach maybe that we need to explore. There's also some hybridization of there's also some hybridization of Chinook and Coho out in the ocean that's changing some of that. Anyway, yeah.
In the state of Georgia, they have a bottleneck study and they have a lot of data looking at fish, Chinook and Coho movements over the first year and a half, and seeing a lot more Chinook and Coho spending at least one winter in the Sailor Sea, and some of our Puget Sound fish going up there in their second winter. So I think there are still people looking at that question and finding surprising and different patterns of residents that might just be like, oh, well, they're there for a year and then should not go out, or people might be there for the whole their whole life. And that changes from year to year, and maybe it's impacted by oceanographic conditions or how big they can get, or if they're too small that first year, they hang around for a bunch of time and then go out. So I think people are looking at that, maybe not as much in Puget Sound currently, but in the Sailor Sea more broadly. Otherwise, photo-wire tag recoveries are sort of limited by what fisheries are open.
And by your
And
size
where that
class.
effort is, so.
And the size class you can keep, right? You don't get data on the juveniles because they're not going to keep them.
Yeah, I brought that up earlier, but we're interested in the indirect effects of harvest seals and the data for that is just poor. So if there was a bigger initiative, which is park and all kinds of fish species that are around here. So that's really, I think there's much data awareness.
And I think too, talking about really with car seals, like almost everything they do is individually variable. Like where they go out, what they eat, like within sectionation strengths, but certain animals we see in our burrows pass all the time, and other ones we see once. And like one we know, like back at the salmon eater, and it was a mammal, and then there's other ones, so I think that kind of data would be really helpful in teasing apart who and what is the biggest problem of, in that section of the problem, many problems that salmon raise.
And there was a study down in Western Alaska where you tagged adult salmon with little pop-up satellite archival tags. And then they were able to get a viewpoint of predation through the lens of the salmon rather than, as we look at it, we can go and collect a sample of scat, seal scat or sea lion scat. But then there's other predators like salmon sharks that we can't see, or we're not detecting them. So by monitoring it through the lens of the fish, you can see things, but you have tag limitations on the size of fish you can tag. And so right now, it can only really do the larger adult size fish, and so you're kind of limited what inferences you can make. But that would be something that would be great to get, wintertime tags out on larger shark in the system in the winter to see what their survivance like. And you can see from temperature signatures, it's marine mammal predator, salmon shark, or say large fish, full blooded fish.
I think one of the gaps that I recognize and think about is like, why are salmon species that are almost primarily marine obligatory, like chum and pinks, doing so well relative to other ones that have a much smaller freshwater, when we tend to speculate that marine environments are driving population responses. So
Habitat and.
habitat and ecology, or
I mean, most of like our green work is showing that in walking systems, it's the limiting habitat and estuaries, with the don't support. Especially with hatcheries, with large hatcheries with certain numbers, and then also pollution.
That makes sense in Puget Sound, but you have the outer coast, those estuaries aren't changed through the years.
Right.
Where they have been.
But they also aren't really, some of them are not really estuaries too, they're just like little freeways.
But I think between pink and chum, I think we're thinking about them, because I mean, Scandit, the chum population has been depressed for many, many years. And we just haven't had a return. Talking to folks at the center. I mean, there's a whole, as a very elegant scientific term, bucket loads of prey out there for chum. And so pinks, I think, is really their climate. But
Well, and also they're starting to support the competition between things, like
There's gonna be
years,
that.
there's so many more numbers of fish that are impacting, if habitat is limiting, then those years, should have pressed, for them.
Any final thoughts? We're coming up to the last 5 minutes. What? Of our meeting.
I think one gap or something I think about, maybe Leslie you mentioned in indirect effects. We talked a lot about predation, but like the bottom up food supply effects, I think about when I feel like at this joint meeting.
John is cheering behind you.
Yeah. Well, I just think like we've had marine mammal recoveries, right? And if there's not a lot of salmon, like our food web productivity is supporting a lot of really big animals and top predators and humpbacks that are coming in and use I don't know, like the fish level, you think about these little fish competing with these little fish. Then you think about one humpback and how many krill that takes up or copepods there. And if we're supporting like more marine mammals, like than we used to, that means that we have a lot more food out there, and maybe I don't know, but maybe for the little fish out there, maybe the food supply and competition issues are bigger.
Well, this is my soapbox really quick. Forage fish. We spend more time saying forage fish, like, it's always been, this is a state problem, this is a federal problem, but I keep saying if I change the words forage fish to salmon fry, right?
And
They-
they're all those silver things about.
They are the ones that bring the food from the zoos up through the food chain.
Marine mammal.
And like salmon, I have been struggling for years to try and work on salmons with Scott and many other people here because they're not commercial, so therefore it's really hard to get funding, but then you can't research them because there's no funding, then you can't, it makes this terrible
It's the
circle.
same thing for porpoises, you're saying, but it's the idea, like these little ones, they're not sexy enough to get funding, but that's the base for everything, and if we could look at that, then we'd be in a lot better place, but nobody will come there.
Won't you guys be excited to know that we're planning Jamie Selleck and from the Forest Fish and Marine, the Forest Fish and Food Web work group, he's not online, but we're planning in the fall, take a salmon. You guys can hold it down if you want.
Yeah.
Yeah.
Jump on that thing there, but John has.
Well, and I think Liz is definitely right, because she agrees with me. But I mean, it's the mismatch part component that data gets at, are the juvenile chinook, for example, going out when the food supply's down here? And they should be waiting, don't come back in the hotel, which is the escort. So I mean, that's the important thing to know what's going on. If we have a real mismatch problem.
Bifurcation of the food web is this horrifying term that circulates in my brain. Yeah, like that's probably Corey Green would give it to me.
Yeah.
Or
Those mismatches in other species, but you totally bottom it out, you're like, I'm here, all true, it's not here.
So I'll throw this out, one more thing. So why, I never, nobody mentioned, why don't we have a pit tag program, a bigger pit tag program in Puget Sound?
Well, you're welcome. So. One of the. Yeah, so there is a collaborative group that is cross boundary and the salmon work group is working with Pacific Salmon Foundation, with Sam James and those guys to bring the collaborators together. And so we've been trying to get Dave Beauchamp and boosting Dave, we have to do certain Dave, but Chris Gregerson from King County and Berger from Puyallup tribe. So there is pit work going on. The salmon work group has eyes on it. I just talked to John White from one of the trees about it yesterday, and so it's going to be part of our work plan that Anna Kate was going to come help me with. She says no idea. And so yeah, it's on our radar. The pit tag work is right for. So then we need. They've got a great system in BC on reporting. That the Pacific Salmon Foundation has sponsored, and then they've got a good with the Tagus group in the Columbia. Hopefully it doesn't go away. But so we're hoping to build something in the Puget Sound that helps. So we've got a coast-wide Tagus like. You want to be chair of the salmon work group, John?
Sounds like it. Maybe one more comment addition before we just close out, and then y'all are welcome to stick around and go. I don't think there's anything in the chat.
Okay,
we just but then we'll close out and you're welcome to kind of stay or hang around before you make your way back or join us for our happy hour. Okay, go ahead.
I don't have any, if you or inspirational comment, mine is very much just surface level, like implementing pit tags at a high enough scale and also in parity for pit tags, we found on the sector is very, very challenging. And so I think that's also, it's like not only a data management limitation, but like it's just a haul of work. And so I think it's just gonna require a lot more.
Well, like we said, there's a whole lot of really rich people in Washington State that aren't paying federal income tax anymore, so.
I wish Casey is not here anymore, right?
No.
That's sort of a question I wanted to ask Casey, and we'll follow up with him on it, but it feels like, especially after seeing your results with the diet studies on harbor seals and getting down to the sex differences, and like, I think California and stellar sea lions deserve the same treatment. And it's been like, I'm getting little glimpses. Like historically, we had better insights into what their diet was, but especially as herring recover and other forage fish, I think it's worth watching that carefully. And expecting a similar amount of like variation between what we see in seals.
All right, everyone, we have made it to 3 p.m. just a minute till. So just want to thank everyone for coming out, joining us. Thanks everyone online for joining as well. Thanks to all of our presenters. Thank you all. Just one more round of applause. Candace, and really think about how we can bring this discussion was illuminating and really fascinating, so I think we'll have a fun debrief.
Yeah, thank you for all your input, energy, ideas, wisdom, and time.
And we'll be following up with a meeting summary in about 2 weeks to all attendees. Also, if you don't know if you signed in when you were coming in, please just make sure your name is on the sign-in sheet as you're exiting. And plugging, we are doing an optional no post happy hour at the Corner Pub. The address is actually on the agenda that was like on the table. If you're interested, or if your commute looks horrible and you're like, I would rather stay a little bit longer, it's about 6 minutes away from here. But you're welcome to kind of hang around as we're cleaning up the space. And yeah, just thanks again for making the trip and participating. So thanks all.
Let's get along.